అది ఇప్పుడు స్క్రీన్ వస్తుంది, ఏమొస్తుందో చూడు, అదే షేర్ అవుతుందా మొత్తం? ఏం చేసినా అదే షేర్ అవుతుంది. ఇది కూడా మినిమైజ్ చేసిన అయినా షేర్ అవుతుంది. వస్తుందో లేదు చూడు, ఒక నిమిషం. ఇప్పుడు ఇదే పెట్టినాక ఇది స్ట్రీమ్ అవుతుంది, అది స్ట్రీమ్ అవుతుంది కాదు. సార్ ఆయన చెప్పరా, ఆయన ప్రొఫెసర్ మన డీన్ ఆయన. ఇప్పుడు ఎన్నో వస్తుంది, వచ్చింది. అంటే ఇప్పుడు మినిమైజ్ చేసి మైక్ ఆన్ చేసి వదిలేనా? మరి మైక్ ఆన్ చేయలేక ఇంకా ఎవరైనా ఏం మాట్లాడితే దొరికేస్తాం. పెట్టేసి ఉంచా.
हेलो हेलो ठीक है। हेलो Good morning everyone. My name is Shubham Gupta and I am a PhD scholar in Department of Electrical Engineering, VNIT Nagpur. It gives me immense pleasure to welcome all the dignitaries and participants to the Gyan course on AI-based methods for the renewable energy integration for smart grid and electric vehicles, hosted by the Department of Electrical Engineering, VNIT Nagpur. As we begin this auspicious occasion, it is a tradition to invoke blessings and set a positive tone by lighting the lamp. To honor this moment, now I kindly request Director Professor Premlal Patel sir, Dean R&C Professor Y.B. Katpatal sir, Dean International Affairs and Alumni Professor K.M. Burchundi sir, and Professor B.S. Umre sir, and Foreign Faculty Professor Himanshu Pota sir to light the lamp and inaugurate this event. Thank you, dignitaries, for lighting the lamp and marking the auspicious beginning of this event. Now I kindly request all to grace the stage with their presence and kindly occupy their seats. Now I kindly request the Honorable Director, Professor Premlal Patel sir, to present a sapling and book to our Honorable Foreign Faculty, Professor Himanshu Pota sir.
बात देना चाहिए ढंग से पढ़ाया नहीं पड़ा वो ढंग से नहीं किया तो दिस ऑल विल बी वेरी एम्बैरेसिंग
Thank you, sir. Thank you, sir. Now I kindly request Professor B.S. Umre, sir, Head of the Electrical Engineering Department, to present a sapling and book to our Honorable Director, Professor Premlal Patel, sir. Thank you, sir. Now I kindly request Dr. M.M. Lokhande sir to present a sapling and book to our Dean International Affairs and Alumni, Professor K.M. Burchundi sir. Thank you, sir. Now I kindly request Professor P.S. Kulkarni sir to present a sapling and book to our head of the Electrical Engineering Department, Professor B.S. Umre sir. Thank you, sir. Now I kindly request Dr. M.M. Lokhande sir to present a sapling and book to our local Gyan coordinator, Dr. Ritesh Keshri sir. Thank you, sir. Now I kindly invite Dr. M.M. Lokhande sir to give course overview and objectives.
Good morning to all the dignitaries on the dais, Honorable Professor Premlal Patel, Director of VNet Nagpur, Professor Himanshu Roy Pota from UNSW Australia, Professor K.M. Burchundi sir, Dean, International Affairs Alumni, respected all faculty members, participants and students present here. It is my privilege to present the overview and objective of this GAN program on AI-based methods for renewable energy integration for smart grid and electric vehicles. So this course addresses a significant needs for developing a new material in two core areas like PV and EV hosting capacity assessment and enhancement, inverter dynamics and control and distribution system to ensure stability and power quality. So in this course, we ensure to increase the quantity of renewable energy integration and also the quality of energy renewable energy integration in the main grid. With growing renewable penetration, especially rooftop solar and electric vehicles, utility networks worldwide are facing new challenges. Many utilities still adopt fixed export limit for the prosumers, overlooking network diversities and dynamics. In contrast, dynamic export limit have been adopted in Australia and in other countries also, and to maximize hosting capacity based on real-time network performance. So this is what we are going to see in the course. Inverters are crucial interface between PV EV system and the grid. This course cover the transformer-based versus transformer-less inverter configuration, leakage current issues, then PWM techniques, harmonic elimination, and inverter control for enhanced power quality. This course is enriched with expert lectures and hands-on tutorial. Topics such as selective harmonic elimination, PV module condition monitoring, EV charging infrastructure, then vibration analysis of the PV system. So what is the effect of vibration on the PV module? And storage integration will be covered in depth, and AI tools and modeling technique for hosting capacity will be demonstrated. We are proud to welcome distinguished speaker including Professor Himanshu Pota and Professor Sandeep Anand from IIT Bombay, Professor Makran Balla from Electrical Engineering Department, Professor Atul Andhare from Mechanical Engineering Department, then Professor Varsha Shah Madam from Electrical Engineering Department, SVNIT Surat. Also myself and Professor P.S. Kulkarni will deliver our expert lecture in this course. Participants in this course come from diverse background, faculty, researchers, PhD scholars, MTech scholars, then professionals who are actually experienced in industry, academia. They're primarily from the field of electrical engineering. We look forward to an engaging week for expert insights, real-world case studies, tutorials, and collaboration collaborative discussions that will advance our understanding and capabilities in integrating renewable energy and electric vehicles into the smart grid. So I hope you will enjoy this course and you'll take maximum out of this course and have a nice day and have a nice stay here, and we'll enjoy the tutorial session also, and all the sessions will be telecasted also, and please keep this session interactive. Thank you.
Thank you, sir, for presenting the course overview and outlining the objectives so clearly. I now kindly invite Dean International Affairs and Alumni, Professor K.M. Burchundi, sir, to share his thoughts.
Good morning, all. Professor Premlal Patel, our beloved director, Professor Pota, our expert guest, Professor Umre, head of the Department of Electrical Engineering, Professor Kulkarni, Professor Lokhande, Professor Ritesh, our senior colleagues, Professor Balla and Professor Andhare. I am very happy that this course is being organized by this department on a very important topic that is close to heart of the whole world. Renewable energy, nowadays it is close to heart of everybody, as you already know, sustainable development goals and all other factors. Not only that, this is further being integrated with the AI background, and that adds another importance to this particular topic. Our generation has grown up while studying all those big equations, e raised to minus t, eta, tau, and so many integrations, differentiations, and so on. And nowadays, I am happy that many of those younger researchers, they are directly using AI techniques to model all those things. Okay? We know those things because everybody might not be comfortable with higher level of mathematics, but nowadays all those things are gradually being replaced by AI-based nonlinear models. The basic importance of those equations, it was to represent some nonlinear system. Fine. As far as this department is concerned, as earlier coordinator of this GAN activity, I was earlier coordinator of this GAN activity, and in those days 22, I will call it first phase. In the first phase, 22 GAN programs were organized, and now also this is 9th GAN program. So this is overall in the institute 31st GAN program, and I am happy to share with you that the share of this institute, VNIT, at national level is very high. Out of around 2,000 courses organized at national level, this is our 30th program, means 30 programs we have contributed, and in addition to that, 5 more programs, they are in the pipeline. And our contribution at national level is, I think, at second or third number. Most of the courses, they have enjoyed good participation from institutes, even like IITs and IISCs. And most of the courses technically have been very highly appreciated by the participants as well as from higher levels also. Like IITs, I keep on getting feedback as I interact with teachers of different institute. All the courses are very highly appreciated. But please note that the GAN activity is not only about sharing technical expertise or having technical knowledge. It is about networking also. And when I talk about networking, it can be at various levels. It might be among us the participants with the institute of the expert, invited expert. It might be with teachers of our institute with the institute from which the expert is coming. It might be within the participants itself. It might be within participants and our institute teachers, and so on. So there are various opportunities of networking. And whenever this networking happens, it will be considered that this particular activity is successful. Earlier, a few of our PhD students and MTech students, they have been offered postdoc as well as postgraduation research opportunities at various institutes all over the world through this particular activity. Not only that, many experts, GAN experts, they have been invited for delivering lectures in different conferences and courses. So I hope, sir, this particular instant marks beginning of further interaction, and the department will invite you for different activities, might be offline, might be online, that is a different case. But definitely networking is very important, sustainable networking, I will say. It is very important aspect of this particular activity. The participants, those who are coming from outside, I must appreciate their enthusiasm and interest in this particular activity. You people are little lucky because now usually in June, Nagpur boils, it goes to 44, 43 degrees, but now it is very comfortable. I hope our coordinators, course coordinators, they have made nice arrangements of your stay and food, etc. So if there is any lacuna from our side, please let us know so that we can improve in our forthcoming courses. However, if you find that the arrangements are good, please do not forget to appreciate that also. Both should go hand in hand. So once again, I welcome all of you to this particular campus on my personal behalf as well as on behalf of my institute, and also as Office of Dean International Affairs. That's all from my side. Jai Hind. Thank you.
Thank you very much, sir, for your insightful and encouraging words. I now kindly invite Head of Electrical Engineering Department, Professor B.S. Umbre, sir, to share his thoughts.
Honorable Director, sir, respected Chief Guest Pota, sir, coordinators of this GAN course, Professor Kulkarni and Professor Lokhande, sir, my colleague, Head of the Department, Andare, sir, Mechanical Department, and Head of the Department for Architecture, Deskar, sir, Dean International Affairs, Burchundi, sir, my other colleagues from teaching staff and non-teaching staff, and most important, the participants. As a head, I welcome you all to this GAN course and to the Electrical Engineering Department. This is a third GAN course from the Electrical Engineering Department. And in the GAN course, in Electrical Engineering Department, we have, as far as the academic is considered, we have BTech in Electrical and Electronics. Then we have 2 MTech courses, Power Electronics and Drives and Electrical Power and System. Then as far as this GAN course is considered, let us have the innovative ideas, get the innovative ideas from this GAN course, do the interactive sessions, and have fun for this getting the knowledge. We are happy to get the feedback from you during the GAN course or after the GAN course. यानी ज्ञान कोर्स के पहले भी और ज्ञान कोर्स के बाद भी. So during with this, I wish you all the best. Thank you.
Thank you very much, sir, for your thoughtful words and valuable perspectives. I now kindly invite local GAN coordinator, Dr. Ritesh Kesari, sir, to share his views.
Good morning to everyone. And good morning to Honorable Director Professor P.L. Patel, our Chief Guest for the and foreign faculty Professor Himanshu Pota. And I just have gone through, like I was just going through his profile, what the work he has carried out. So his contributions are like you can say that extremely contributory in nature so far. And I also welcome on behalf of National GAN Coordinator to our institute for this delivering the GAN course. Regarding the GAN course, it has started in 2016, and at VNIT with the initiation of Professor Buchandi also. At that time, VNIT has started this GAN course, and so far three phases of the GAN course is completed, in which around 2,200 courses have been delivered at the national level, and this is the fourth phase of the GAN course going on, and fifth phase is yet to start. And so in fourth phase of the GAN course, total 339 courses are approved, and out of which 11 courses are approved at VNIT. We had submitted a total 36 courses, and we got 11 courses. And from the electrical department, this is the seventh GAN course what we are organizing. So with this number, electronics department and electrical department both have contributed same number of GAN courses. And we are the leader in also taking the opportunity with the interaction of foreign faculty members, with the start of new areas like molecular communication, then in communication, then biomedical, electric vehicle systems. So all those three initiations were the outcome of the GAN courses. Similarly, recently, Dr. Arghya Mitra has also organized a course in which power system stability and all these related areas are coming up. And we have a very strong relation with the Professor Borghetti from Italy. And from the Australia, so far 109 courses are organized. So this is an opportunity for us also. So as Professor Buchandi explained, that intention of the government is that we want to and we are organizing these courses with the thought that more number of faculty, students and research scholars get interacted with the foreign faculty, so that we can work in the area which are in which other countries are leading, and they have already taken initiation. And so just intention is that we all work together in line, on time, and so for the benefit of the country itself. And so we also want to contribute to the benefit of whole of the world. Like you see that nowadays we are just in parallel with all the foreign countries. So with this, I welcome you all and Professor Himanshu Kota. Thank you.
Thank you, sir, for sharing your valuable insights with us. I now kindly invite Professor P.S. Kulkarni, sir, to introduce Professor Himanshu Pota, sir.
Good morning, everybody. It gives me immense pleasure to introduce to you foreign faculty, Professor Himanshu Pota, who is a distinguished academician in the field of electrical engineering, currently affiliated with the School of Engineering and Technology at UNSW Canberra, Australia, since February 1989. Dr. Pota's extensive educational background includes BE in Electrical Engineering from Sardar Vallabhbhai Regional Engineering College. What is SVNIT today is now, that time it was Regional Engineering College, Surat, India in 1979, followed by ME from ISC Bangalore in 1981 and PhD from University of Newcastle, NSW Australia in 1985, all in electrical engineering. Throughout his career, Professor Pota has held several significant visiting appointments at prestigious institutions globally, including Columbia University, New York City, the University of California, Los Angeles, the University of Delaware, Iowa State University, Kansas State University, Old Dominion University, University of California, San Diego, and Center for AI and Robotics, Bangalore. His research has made a substantial impact, significant gap as evidenced by his prolific publication record. He has authored more than 246 refereed journal papers, 2 books, 15 book chapters on over 277 international conference papers. His work is highly cited with 9798 Scopus citations and H-index of 51 and Google Scholar H-index of 61 with 13,723 citations. Notably, from 2016 to 2020, 30 of his articles were published in the top 10 journals by SNIP, and he has maintained an average of 10 Q1 publications over the last 8 years. With this, Professor Pota's significant contributions to the academic community also include his role as an associate editor of the IEEE Transactions on Control System Technology and editor-in-chief also. His published books include The Essential of Power System Dynamics and Control in 2018 and Robust Control for Grid Voltage Stability, High Penetration of Renewable Energy in 2014. Co-authored with J. Hossain. His recent journal articles from 2024 cover diverse topics such as self-organizing control systems for UAVs under wind disturbance, electric vehicle hosting capacity analysis, which is the topic of the course, and chattering-free fixed-time robust sliding mode controllers for grid-connected inverters. His work also extends to fault classification and location in distribution networks using deep convolution neural networks, automating distribution networks for efficient fault management, and systematic approaches to designing power sharing control of converter based generators. With this, I welcome you, sir, to our department. Thank you for accepting my invitation.
Thank you, sir, for the kind introduction of our esteemed guest. It was truly an honor to learn about his journey and contributions. I now request Professor Himanshu Pota, sir, to address the gathering.
Thank you very much. Oh, it's a bit difficult to know how I can meet your expectations. I have been in this business for very long. So obviously all the publications are there, that is there, but it is nothing. It does not matter, all those things don't matter if we don't have a nice course, right? So that's the whole thing I am focused on. And all, thank you for your welcome. I mean, I can see all the protocols here, and it's such a minefield. आप लोग कैसे करते हैं मेरे को पता नहीं. एक तो जूते निकालना, फिर जूते के हाथ धोए बिगर लाइट करना, फिर मोमबत्ती लगाना. हमारे एक मित्र थे, वो मोमबत्ती के बहुत विरुद्ध थे, बिकॉज मोमबत्ती इज मेड बाय 20 को उसको उससे निकाल के. So yeah, it is a minefield. आप लोग करते हैं, that is all very good, but I don't know how can you do it differently. But all the traditions are very good. We do it ourselves also. So कल मैं किसी को, मैंने हमारे एक मित्र को मैसेज भेजा कि मैं बॉम्बे में उस लाउंज में था, अडानी लाउंज में, because I had some time. तो मैंने कहा जितनी महिलाएं यहाँ साड़ी में हैं उससे ज़्यादा JFK एयरपोर्ट न्यूयॉर्क में मैंने देखी है. So we sometimes, I think, follow more traditions than people follow in India. So, but it is all very good. Thank you very much for that. और जब आपने मेरे को नारियल दिया था, मेरे को याद आया, I was in a school. हम स्कूल के टूर पे गए थे, तो एक ढाबे में, there are many dhabas with unlimited आप खा सकते हो. So I think I had already 10 rotis. तो फिर वो नारियल लेकर आया कि आप हमारा ₹1.25 मत दो, नारियल लो और जाओ यहाँ से. So I hope that's not the nariyal today. You take nariyal and go. इसलिए मैंने कहा you should have, all these things should be at the end, depending on how the material is developed. I have been quite stressed about the material for this course, honestly, because I thought I'll try something new, something different. And being in this business for very long, you look for very special things to see whether they are really impactful or not. Publications, yes, we write publications, but not all publications have got an impact. But it is an important thing to be in the system, because PhD students have to write publications to get their PhD and all that. So I have been quite stressed because I'm trying to locate or identify what are the things which have made impact in the power systems. See, it is many people do data processing. Many of my PhD students have gone out to the industry. और मेरे को समझ ही नहीं आता वो क्या कर सकते हैं. जो PhD कर रहे थे उनको कुछ नहीं मालूम था, तो इंडस्ट्री में क्या करते होंगे. So all these things, I'm really struggling with all this whole new smart grid and all that, as to where we are and what are the important problems, where can we make a difference. So I've been thinking with that. आपने कहा कि I visited many universities. So it is not a credit to me, but I I would like to mention that to you because I have had the privilege of working with very high impact researchers. और उनसे मैंने सीखा, मेरा भी थोड़ा अनुभव है कि रिसर्च क्या होती है, कैसे करी जाती है. So my desire, if you like, is for us to get together here. So I'm sure that many of you would want to have a good research career after that. If you're doing your PhD, make an impactful PhD. From my experience, I can sort of validate your ideas about research or say this is not what will lead you to good research, this is will what you lead to good research. That's what I can do. I mean collectively all of us can do, and that would be a very satisfactory outcome for me, that you can come and discuss with us that this is the type of research I am thinking of, or these are the problems I think are the really problems. कई बार क्या होता है कि at our level हमको लगता है ये तो क्या है, कुछ नहीं है. But the whole most important thing is something you have thought of yourself. So many things I will be presenting in the next 5 days are very small and little, but some of those things or most of those things I have thought about it myself, so they are very important to me. So it is not chasing somebody else's research, but thinking about research as your own thing, your own baby. So that is the best contribution I can make towards your career or towards your research. Okay, that's what I do for my PhD students. That's what we do for other. We have got panels to supervise, to review other PhD students. That's one of the very important roles we have. And I bring it out to you because I want you to feel free to suggest even tiny little thing you have thought of yourself. That can it be developed into a full-blown research? And that's what I would like to interact with you. And that's very exciting because I get to hear about what other people are thinking. And believe me, मैं आपके idea चोरी करके नहीं जाऊँगा. I have not done it so far. I'm not going to do it anymore. So I'll be very happy to share with your ideas. And I am quite stressed, to be very honest. And I hope I can meet your expectations. Thank you all for welcoming me here. And it is really very touching when somebody goes out of their way. मतलब हम तो वो जो नारियल वाला, I am the same boy there जिसको नारियल लेकर भगा दिया गया था. I am the same boy. और प्रोफेसर पटेल जिस कॉलेज में थे वहाँ मैंने कितने क्लासेस बंक करा है, there is a big record there. So I am the same person. So let's have a very nice and interactive session. Thank you very much.
In the light mood, I will like to add one more thing. In the Srifad,
Yes.
that we call Nariyal,
Yeah,
is with shawl,
Yes.
then it is welcome. If it is only
Okay.
then it is
Thanks.
with respect. Welcome. Yes.
दिया लगाना important है सर.
I fully, मैं just कह रहा हूँ कि how big protocol problem all these things are.
सर के
They
लिए
are not
तालियां,
easy.
सर के लिए तालियां हो जाएगी. सर का नाम अभी भी SCNIT के डायरेक्टर रूम के सामने लगा है, ऐसा सर ने बोला. Very good for that.
Thank you very much, sir, for your inspiring address. Your insights and experiences have truly enriched this occasion and motivated us all. I now request the Honorable Director, Professor Premlal Patel, sir, to guide the participants.
Very good morning to all of you. Our Gyan expert or resource person, Professor Himanshu R. Potaji from University of South Wales, Australia, Head of Department Electrical Engineering, Professor B.S. Umre, our Dean International Affairs, Professor Barchandi, Gyan Coordinator at the Institute level, Professor Kesari, our heads of the department, of the departments, our faculty members, participants of this Gyan Coordinator,
who are in the online or offline mode. Welcome you all in this very nice gathering wherein we are in the process of inauguration of this Gyan course. I think it is for a week time. 5 days duration. As we said, I'm very happy to see that Professor Himanshu Bota, as you said, that he's from our original institute, Sardar Vallabhbhai Institute of Technology. So I'm very happy and touched that you are here, as because he's basically the alumni of SVNIT. Now he came here for delivering this very nice course. I'm sure you would enjoy his lectures because he was the gold medalist at this point of time in SVR Engineering College, now SVNIT. As far as this Gyan course is concerned, in VNIT, particularly as said by your Professor Kesari, that Department of Electrical Engineering and Electronics Engineering, they are doing wonderful as far as the organization of this Gyan course is concerned. Other departments are also there, but not that much, you can say, encouraging. But I'm sure that other head of departments and faculty members should take the lead in conducting such kind of program, because Gyan means Global Initiative for Academic Network. I mean, when Ministry of Education, Government of India, their focus is now internationalization of education. And in that direction, they have initiated this program. So when Professor Himanshu or can say similar kind of resource person comes from all over the globe, the purpose of this course is that all participants should get networked with the resource person, and also wherever such can say resource person comes, like VNIT at this moment, so our faculty members should be get interaction with him at the most, so that we can have joint research publications, joint research project. We can have MOUs. MOU could be at the institute level, so that other departments can also be part of it and develop this academic activities at the institute level. I think such kind of initiation should be there. In the last Gyan course, when I participated here, I have told very clearly to Gyan course coordinator, who was their local coordinator at that point of time. I think the professor came from France, and I told that you must have such kind of MOU, but I could not get even today such kind of MOU. So I think this should not happen. At least when our resource person are here, at least for a week time, we should establish some good relations and take it further. It is not simply giving just simply a course, because giving simply course may happen in STTPs also. So what is the difference between STTP and Gyan course? So this should be altogether different thing. Purpose of this Gyan course is altogether different. I'm sure with your participation, all our participants, our faculty members present over here, they will take the maximum advantage of Professor Himanshu. He is here for say 5-6 days, and we will take it further. As far as this particular course is concerned, that is your AI-based methods for the renewable energy integration for smart grids and electric vehicles. I could see previously the AI were focused in the area of computer science engineering or electronics engineering, but now the role of this application of AI should be in other engineering discipline also. Like this is very good, nice, can say, Gyan course wherein application of AI is also included. I'm sure that such kind of, you can say, courses would be there in other departments also, and the application of AI should also be included in other, you can say, engineering departments, because the head of departments are present over here. So with this, I can again convey my congratulations to local Gyan coordinators, Professor Kulkarni and Markan Lokhande, for organizing such beautiful Gyan course, and I'm sure that we'll get the maximum advantage out of it. Thanks for inviting me for this program, and wish you all the best. Thank you very much. Thank you.
Thank you very much, sir, for your encouraging words and valuable guidance. Your support and vision are truly inspiring for all of us. Now I request Dr. M. Lokhande, sir, to propose the vote of thanks.
So first and foremost, I would like to express our heartfelt gratitude for our chief guest, Professor Premlal Patel, Director of VNIT Nagpur, will surely ensure what will be the next after this GAN course. And very special thanks to Professor Himanshu Roy Pota from University of New South Wales, Australia, for accepting our invitation and joining us as an international expert. We are deeply privileged to have your presence in this course, and he is very supportive from the beginning. Professor Burchundi sir for his valuable remarks on this course. We also express our thanks to the head of the electrical engineering department for unwavering support. Also the presence of head of the department architecture and planning and head of the department mechanical engineering, Professor Andhare and Professor Samir Deshkar. Our sincere thanks to account section, network center, electrical maintenance section, security section for providing necessary help, and also for the hostel office and guest house team. A special thanks to the office staff, Mr. Boyer and Mr. Kamlesh, and also heartfelt thanks to our smart and energetic students, Srinivas, Vinay, Sai, Shubham, Yash, Payal, Murli, Shrestha, and Vedika. Finally, I express my gratitude to all the participants from academia, industry, and research for showing keen interest in this course. Your presence enriches the academic environment we aim to foster. With this, I conclude the inauguration session and warmly invite you for the high tea. Thank you. Okay, national anthem. जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविण उच्चल वंग विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंग तब शुभ नामे जागे तब शुभ आशीष मागे गाए तब जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे भारत माता की जय. Thank you.
All these are very competent people. आपको चिंता की बात नहीं है.
वर्किंग ही बनाएंगे बहुत ज़्यादा इम्पोर्टेंट है. काम चलता है ऐसे ही अच्छा रहेगा. मीटिंग है.
अरे आपको मेरे को पता है कितनी ऐसे छोटे छोटे बहुत होते हैं. I understand sir, I understand. I fully understand.
आधा घंटा लिया था.
Kindly join us outside the hall for refreshment and informal interaction for high tea.
ఇప్పుడు బ్లాంక్ స్క్రీన్ వస్తుంది. బ్లాక్ అంతే, బ్లాక్ వస్తుంది, ఆ డిస్ప్లే రాదనమాట. అవుతుంది పోతుంది మంచిగా. బ్లాక్ స్క్రీన్ పెట్టాలా, ఇది వస్తుందా మళ్ళీ వచ్చి ఏం కెలికాను అనుకో పీపీటీ రాదు. అలా ఇంకా బ్లాంక్ స్క్రీన్ పీపీటీ రావట్లేదు. వస్తుంది అంటే ఇప్పుడు దీన్ని నేను కనెక్ట్ చేయాలి, దీన్ని షేర్ చేద్దాం అంటే ఇప్పుడు నెట్వర్క్ సెట్ చేసుకోవాలా. స్క్రోలింగ్ చూసా ఉన్నా. అవును, అసలు ఆయన ప్రెజెంటేషన్ ఏద్దాం అనుకుంటున్నాడు. నా ల్యాప్టాప్ ఏది, నా బ్యాగ్ తీసుకుంటా. నా బ్యాగ్ ఇక్కడ ఏదో చేయాలి. ఏం చేయాలి ఇప్పుడు? ఇది ఆపేయాలి కదా. ఇప్పుడు లెక్చర్ ఓకే, ఇది ఆన్ అయింది. సార్ డబ్బాలు పెట్టాం. సార్ అదే వాటర్ బాటిల్ ఒకటి తెచ్చిచ్చారు కదా సార్. యూట్యూబ్లో ఏమొస్తుంది చూడ, అయితే ఫుల్ స్క్రీన్లో ఉన్నారు. ఓకే ఆ సైడ్ బయటకి త్వరగా చాయ్ తాగండి, వాటర్ పట్టేసి వస్తుంది. పట్టుకుని చాయ్ పడతారు. ఓకే, ఇది స్ట్రీమ్ అవుతుంది. ఇక్కడ కనిపిస్తుంది, లైవ్లో కనిపించదు. అదే నా ఛార్జర్ కూడా తీసుకున్నా సార్. ఆయన కూర్చొని మాట్లాడితే, నిలబడి మాట్లాడితే లో కండిషన్ అడుగు సార్. ఇక్కడ మార్చాలి सर, माइक बंद कर दे सर. हाँ नहीं सर, आप जाइए सर. Yes, good sir. Okay. Oh, what is this? Something fishy. ఓకే, ఇక్కడ ఆడ వస్తే బాగానే ఉంటుంది. స్పీకర్ ఈ కెమెరా అట్లా తేడాగా ఉంది. ఏదో జరిగింది. ఏం జరిగింది? ఓకే, సో ఇది ఆఫ్ చేయాలి, ఇది ఆన్ చేయాలి. థ్యాంక్ యూ.
స్కోరింగ్ बोले
స్కోరింగ్ తీసేస్తాను. అది తీయాలని చూస్తున్నాను. తీసేమని చెప్పిండు సార్, మొత్తం అంతా కన్ఫర్మ్ చెప్పింది.
తీసేయాలి కదా మళ్ళీ ఎట్లా
పైది ఉంచుదాం బ్యానర్ టైటిల్. అది ఐకాన్స్ డిస్టర్బ్ చేయట్లేదు. ఎట్టుగా కింద తీసేద్దాం.
సరే కింద తీసేసి డిస్ప్లే టు వీడియో టిక్ కొట్టేసి
సరిపోయింది.
అప్లై కన్ఫర్మ్ కన్ఫర్మ్. ఇప్పుడు పీపీటీలో ఆ ప్రజెంటేషన్ పెట్టేసి
సరిపోయింది.
ఇప్పుడు ఈ ప్రజెంటేషన్ పెడతాయి.
ఓకే, ఇది కూడా పై ఇందులో ప్రెజెంటేషన్ వస్తుంది కదా. సార్ పక్కన అయిపోయింది.
ఈ కనెక్షన్ సక్సెస్ఫుల్. లైవ్ ఎట్లా వస్తుంది? బ్లాంక్ స్క్రీన్ వస్తుంది.
ఫుల్
ఓకే.
ప్రస్తుతానికి ఫుల్ స్క్రీన్ చేసి ఉంచేద్దాం.
ప్రజెంటేషన్లో పెట్టి పెట్టినావా?
ప్రెజెంటేషన్లో పెట్టి అక్కడ బ్లాక్ స్క్రీన్ పెట్టేస్తాను.
బ్లాక్ స్క్రీన్ వస్తుంది ఇప్పుడు.
అవునా? అయితే ఓన్లీ ప్రెజెంటేషన్ ఇక్కడ మనకు మాత్రం కనిపిస్తుంది. ప్రెజెంటేషన్
మళ్ళీ ఇప్పుడు అడగాలంటే ఎట్లా చేస్తావు?
యాడ్ చేయాలంటే
ప్రజెంటేషన్
ప్రెజెంటేషన్ అందులో కనెక్ట్ అవుతుంది. అది వీడియోలో కనెక్ట్ అయి ప్లే అవుతుంది.
ఇప్పుడు ఇది ఎట్లా వస్తుంది? ఇందులో ఎట్లా వస్తుంది?
ఇందులో నేను స్ట్రీమింగ్ స్టార్ట్ మళ్ళీ ఇప్పుడు బ్లాక్ స్క్రీన్ ఉంది సార్, అది వైట్ అవుతుంది. ఎప్పుడైతే కాన్ఫరెన్స్ దాంట్లోకి వెళ్ళినప్పుడు కెమెరాలు వస్తాయి కదా, అప్పుడు ఆటోమేటిక్ కనెక్ట్ అవుతుంది. లైవ్ ఆగిపోకుండా ఉండాలి అంతే. అది सबको अंदर बुलाओ.
Yes.
फोल्डर आपने
Yes.
वो डॉक्यूमेंट आपके
Yeah, correct.
इसमें I have installed Anaconda and MATLAB is already installed.
Okay.
आपको जो ओपन करना है बताइए. हाँ अभी तो से ओपन कर.
Okay. So we open this, right? अभी तो ये
बाहर टैग करना. हाँ कैमरे से.
same here.
हाँ सर आपको इधर दिख जाएगा.
Yeah, yeah.
हाँ नहीं सर वो माउस अलग उसको कंट्रोल.
इसके हो.
सर मैं आपको वायरलेस
हाँ हाँ मेरे को उससे मैं हाथ से मेरा चलता नहीं. So I can click here.
नहीं सर ये इसका माउस है. इसमें दिखेगा सर.
इसमें दिखेगा. और
हाँ सर.
अभी तो नहीं चाहिए पर हाँ मतलब MATLAB does MATLAB need anything?
हाँ सर MATLAB है सर.
है?
MATLAB के
Okay.
लिए तो आप इसके इससे
But,
बाहर
but
आ.
it is all installed everything, right?
हाँ, sir,
That's
everything.
I don't need internet. अरे माइक सब सुन लेंगे मेरी आवाज तो वैसे ही. पर हाँ रिकॉर्ड कर रहे हो तो I don't know.
Turn on the mic.
So I don't know how recording will go. For that you might need wireless mic, right?
हाँ सर.
हाँ तो क्यों चाहिएगा. I mean people here can listen no doubt. हाँ रिकॉर्डिंग कर रहे हैं तो.
हेलो सर. हाँ सर. हाँ सर इधर तक तो कवर हो गया. इसके इधर इधर. हाँ उधर लाइट्स ऑफ कर देंगे सर. हाँ हाँ सर. इन दिस रेंज.
Okay.
Movement. Cover in camera.
यस. చార్జర్ లాస్ట్లో ఉంది ఆ బ్యాగుల దగ్గర చార్జర్ నా బ్యాగ్లో ఉంది అంటే వైట్ నాకు కనిపిస్తుంది देख लीजिए ना साथ
Okay, yes, yes.
ये सभी आप जो फाइल्स भेजे थे मैं सभी ओपन करके रखा था
They're okay. We'll need it maybe in the second session, but that's fine.
आप ये यूज़ करके स्टोर कर सकते हैं
Okay. Oh, okay. So ये है okay.
अगर
Shukran. Okay. So thank you very much. Now, how many are PhD students? 1, 2, 3, 4. Okay. 5. And how many are faculty? Okay, 4, 5. Okay, that's good. Thank you very much. And Nagpur से बाहर से कितने? Oh, quite a few from outside Nagpur. So welcome. Welcome for taking the trouble. So, firstly, we set up what are the very essential ideas to do any research. Now, our area is sort of power systems, right? So we are getting into this AI business, machine learning. So we do that, but people who do machine learning and for whom it is bread and butter business to do optimization, all that, they will any day beat us, right? Because they are always ahead of us. So what can we contribute? That's one thing I want to sort of focus on this through discussions, through interaction, through whatever ideas I have, through whatever ideas you have, as to what as power system engineers we can contribute to that. Because people who do optimization, they'll beat us any day. So it's not really worth our while to get stuck into just the optimization business, because that's not what we do. And they can't do whatever our expertise is in power system, they don't have it. Okay, so the whole idea, and it's apart from this personal space for research, the important thing is that are there any problems out there which need our expertise? Is there any problem out there in the field, in the power industry, which can benefit from our expertise? So if we are not needed, we might as well do something else, right? What's the point of doing things which are not essentially needed? So one of the most powerful tools we have as electrical engineers or any engineer is feedback, right? If there is no feedback, we are not needed, right? Our whole purpose of engineering is, at least electrical engineering, to use feedback to improve performance. Correct? Does that make sense? Whole idea is to use feedback to improve performance. If there was no feedback, we are not needed. If it was just open loop, we are not needed. So we have to very carefully see how we can use feedback to do various things. So right now in power industry, many things are done in open loop, all the data processing and what they do and how they schedule things, and most of those things are done in open loop, really. If we have to close the loop, what should we do? Now, I have got a very small exercise for all of you. असल में ऐसा हुआ, ये इतने लेक्चर वगैरह सुन के नहीं करना था, मेरा सारा दिमाग उलट पुलट गया. For the last week, I was highly focused on that, but I will recollect it. So, this is what I want you to do. शुरू में है अपने पास इरेजर है? हाँ, ये बस है. Thank you very much. Okay, सर का अपनी बात होती है. I started getting a feel for this whole thing, feedback business, because this is historical introduction of feedback. So what is this? So these are amplifiers, electronic amplifiers to amplify the signal, and we can model the noise coming, additive noise at the output. And we have got an output S0. What is the problem with that? Can somebody say? What is the problem with this on the left hand side? Faculty needs first PhD students and then, yes, ma'am. With the noise, signal to noise ratio is low. So इसमें आपका क्या problem है? Signal to noise ratio low. And if you have got multiple amplifiers, which you have got in communication system, repeaters, what happens to the noise? The noise there is no difference between signal and noise here. Oh, sorry. Yeah, there is no difference between this. This is exactly the problem. This is very, very important what we are going to discuss now. This ringing. So here in this S0, there is no distinction between the amplified signal and the noise. They are both in the subsequent stages, they are amplified the same way. Now this was the breakthrough solution which changed the world. On the right what you see is the solution which changed the world completely. Agar wo nahi hota, so there is nothing we could do. Now you could see this ringing and the noise would have been so dominant that we could not hear anything. So now, iska, if I may say so, SNR high, right? Signal to noise ratio is very high on the things on the right side. So आप मेरे को अपने notes में करके बताएं that why SNR is high on the right side, low on the left side. So आपको काम करना पड़ेगा थोड़ा. So आप signal to noise ratio निकालें इसमें. So that is, what should I say? We can say it S. Okay, we can say it S here. And then the signal to noise ratio इसका, इसमें कितना signal है और कितना noise है और इसमें कितना signal है. So basically what I want you to do is, Okay, what I want you to do is this. So S out n times something plus Si times something, and signal to noise ratio is okay, so वो तो ठीक है, signal to noise ratio. I want you to write the S out. उसमें कितना signal है, कितना noise है. Get me the signal to noise ratio on both the configurations and tell me why signal to noise ratio is high on the right hand side. Or is it? Maybe it's not. दुनिया ने आपको बेवकूफ बना दिया. क्वेश्चन समझ में आया? ये बहुत इंपॉर्टेंट क्वेश्चन है. इलेक्ट्रिकल इंजीनियर की जिंदगी इस पर निर्भर करती है. मैं आई एम नॉट एग्जैजरेटिंग. क्वेश्चन समझ में आया सर? वी नीड टू राइट एन एक्सप्रेशन फॉर एस नॉट, राइट? एस नॉट इज हियर, and then it will have two components, one to do with noise, another do with the signal, and then take the noise signal component divided by noise component, that will be signal to noise ratio, right? बहुत साधारण. लेफ्ट में भी राइट में भी आप सेम काम करें. और मेरे को बताएं कि सिग्नल टू नॉइज रेशियो हाउ इज इट इंप्रूव्ड इन द राइट हैंड साइड. इसका फॉर्मूला तो सबको मालूम है. मतलब यू up to you whether you want to use formula or derive yourself or whatever you want to do. Anything you have, you ask me. या एस नॉट, या सो आप ये भी एस नॉट ही है. फीडबैक इज ऑल्सो एस नॉट. सो दिस इज a linear system, right? So you can do two things. One is put this to 0, get your transfer function, then put that to 0 and get your transfer function. कर लिया मैम आपने? तो सिग्नल टू नॉइज रेशियो क्या है? सिग्नल टू नॉइज रेशियो, सिग्नल इज हियर. सो आप सिग्नल टू नॉइज रेशियो लिखे ना, ये SNR. सो जो भी आउटपुट में सिग्नल का टर्म है वो यहां लिखें और नॉइज का टर्म यहां लिखें. यू गॉट इट, बट जस्ट यू हैव टू सेपरेट द टू. तो आपका ये सिग्नल, सो ओके गुड. सो यहां नॉइज का कंपोनेंट है 1. यहाँ आना चाहिए, ऐसा इसमें नहीं आना चाहिए. Yeah, this is the output. Correct. Correct. So you already have it. So आपका सिग्नल ASI है और नॉइज N है. So that is signal to noise. ठीक है. सेम आपको नीचे भी करना है. It is simpler than you think, but not simple to interpret the result. Yes, sir. So signal to noise ratio ये आपका आया. ये तो आपका ये है signal to noise ratio. Okay. So the second. So what is the noise here? Signal here. SI. ASI. So this will be A. ये वाला. हैं? So signal is ASI. What is the noise? N. So signal to noise ratio is this, right? Same way you can do it later. Okay. Well, I'll show. I think couple of our friends have done it, but maybe you are making it a bit more complicated than it is. So let me do it simple. So output is ASI plus N. That's the output. So signal to noise ratio is simply ASI on N. Right? Because in the output, what is signal? Signal is ASI. What is noise? N. So there is a signal to noise ratio for this. Same way, exactly what you have written here, you have to write that, but these things, A will be something else, and these two expressions will be something else. So first you have to write like that. ठीक है? तो आपने लिखा, very good. उसको simplify कर ले. Very good. Okay. कहीं गलती है. That's fine. नहीं, ये नहीं, ये सही नहीं है. This is not right. फिर आप ऐसा करें, just put that to 0.
Yes, sir. Yes, I put this, so these become in cascade.
Yes, so it is still feedback, right? अब यहाँ से ये this and that, so you can write and you will see that you will also get a feedback equation. आपने आधा, so you can put that to 0 and derive it. Okay, when you put that to 0, S naught equals to N minus A beta S naught. Okay, then, right? So S naught equals to N on 1 plus A beta. ठीक है? कोई मैजिक नहीं. इलेक्ट्रिकल इंजीनियरिंग का आधार इस पे है. आई एम नॉट एग्जेजरेटिंग. अगर आपको ये समझ में आ गया तो यू स्टार्टेड ऑन इलेक्ट्रिकल इंजीनियरिंग. Not just deriving this, but to interpret it. हो गया भैया? Yes, ma'am, हुआ? So this is alright, but then you have to write signal to noise ratio. That's it. आपने लिखा, मतलब you have to get it here, write it in this way. There is some term here, some term there, but it should be N here, SI there. Yes, sir.
I tried, sir.
No, I'm sure that
S naught.
S not, पर ये यहाँ आप देख रहे हैं, मैंने वो ऊपर बताया जो, because N, because here, see, okay, what I would suggest is that write it two different ways. One is put N equals to 0, so you should do that. SO on SI, N equals to 0, and SO on N, SI equals to 0. ये दोनों अलग अलग लिखे and then put it together. Superposition. बहुत तकलीफ हो रही है, राइट? हैं? धीरे, तो क्या है? Tell me. So why is that right one change the word? क्यों उसने दुनिया बदल दी? And that's a matter of fact. What you see on the right change the entire world. क्यों? आपको तो सेम एक्सप्रेशन आ रहा है आंसर. तो क्या फर्क है? The answer to that is very critical, and that is फ्रॉम प्रैक्टिस, फ्रॉम प्रैक्टिकल नॉलेज। आप सोचिए क्या फर्क है। यू गॉट इट राइट। वेरी गुड, अनदर आवर फ्रेंड सेज सेम। आपने मैं करें धीरे, यू हैव टू डू इट धीरे 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 धीरे। ओके, सो at least 2 of our friends have got the answer, and that answer is not so earth shattering that it will change the world, right? जो आंसर आपको दिख रहा है उसमें तो ऐसा कुछ नहीं दिखता, पर क्यों उसने दुनिया बदल दी। अगर फीडबैक नहीं होता तो कुछ नहीं होता। यू एग्री, राइट? Without feedback, we would have none of these conveniences in life. Feedback is essential. तो क्या है? मैं थोड़े मिनट और देता हूं। Unless you do it yourself, you will not feel good about it. आप कर लें? किया आपने? मतलब उसको जो राइट हैंड साइड पे है, राइट टू ट्रांसफर फंक्शन, दैट्स इट। दिस इज वॉट यू शुड गेट। सब में आया? अब आप सिग्नल टू नॉइज रेशियो लें। यू नो सिग्नल टू नॉइज रेशियो हियर, सेम वे यू टेक इट देयर। बताएं अब आप।
It's A on both the cases.
तो क्या फिर? यस, यू आर राइट। पर किसने इसने दुनिया बदल दी? What was the inside Mr. Blake had? I think उसका नाम ब्लेक ही था कुछ, जिसको ये इंसाइट आई। जो उसका ब्लेक का आई थिंक 50 या 60 साल, 50 साल बाद, when he discovered this feedback, 50 years later he was interviewed. तो उन्होंने कहा कि आज भी मैं नहीं कह सकता, 50 तब भी मैं नहीं कह पा सकता था, और आज भी नहीं कह सकता कि एक इंसाइट मेरे को आई कैसे। Because world is trying to figure out how did he really think of it. तो उसने कहा 50 साल बाद भी said I can't even today say, मैंने बहुत सोचा है, for 50 years I have thought that how did I get this insight, and even today I can't say how. So this is दुनिया बदल दी इसने। But they had the insight because they were practical engineers. So वो मैं नहीं कह रहा। So if do we have that insight, क्यों बताएं? Okay, so all those people who have come up with the answer, just try to figure out what in numbers, in a practical amplifier, what will be A here and what will be A there. आप ये सोचिए from practice. नंबर अब लगाएं, आपने सिंबल्स यूज कर रहे हैं, आप नंबर लगाएं कि लेफ्ट में A क्या होगा और राइट में A क्या होगा। Just think of numbers. Suppose you are designing an audio amplifier. आपने क्लासरूम में बहुत बार पढ़ाया होगा audio amplifier with this gain. So what will be the number A there, real number, और वहां राइट में क्या नंबर होगा और बीटा क्या होगा। Anybody needs help with that? So here SNR is this. If you continue the same way, SNR will be A on SI on N, both. Signal to noise ratio दोनों जगह एक ही होगा, symbolically. But practically speaking, आपने अगर किसी ने, I mean I have done it but not very well, किसी ने ऑडियो एम्पलीफायर कभी डिजाइन किया है या क्लास में पढ़ाया है या somehow So what is the typical gain you have got for audio amplifiers? 20 dB? 20 dB तो बहुत, suppose gain 100 है, right? So आपने ये 100 हुआ, right? Suppose you are designing an open loop, और डिजाइन कर सकते हैं, उसमें कोई ऐसी बड़ी बात नहीं है. You can design an open loop amplifier, that's fine. तो वो A वहां क्या होगा राइट हैंड साइड पे, टू गेट अ गेन ऑफ 100. ये नंबर क्या होगा? टू गेट अ नंबर ए क्या होगा? ऑप एम्प का गेन क्या होता है? ऑप एम्प, ऑपरेशनल एम्पलीफायर का गेन कितना होता है? ओपन लूप गेन. अब ऑप एम्प तो आप सब काम में लेते होंगे, तो उसका गेन कितना होता है? वेरी हाई. 1 लाख, लेट्स से 1 लाख, 10 लाख, something like that, right? So you use an op amp here. So what do you want? A on 1 plus A beta, you want 100, right? If you use the right amplifier. And let's say I put beta, मैंने आपको दे दिया, I put beta as, or beta roughly as 100, I say. Let me put beta roughly as 100. Wait, I'm very sorry. 1 on 100, I'm very sorry. तो A बताएं कितना होगा? That you can do the calculation. A कितना होगा? Or choose beta as 99 or 101 or whatever you want. कोई बता सकता है कितना आया? आप लोगों से इलेक्ट्रॉनिक्स कितने पढ़ाते हैं? How many of you teach electronics? No? Keep it 99, 1 on 99 or 1 on 101 or whatever. 1 on 99, keep it 1 on 99. Something like that. Or you can just eyeball it. You can eyeball it. कितना होगा? A 100A 100 plus A. No, 100A 1 on beta 100A. So कितना होना चाहिए A to be this to be 100? ये सिंपल, यही है ना अपना प्रॉब्लम. तो कितना, क्या A होना चाहिए? Yeah, just give me a rough, what do you think A should be? Small?
No, actually one. Should be one.
1 होगा तो गेन 1 हो जाएगा ना. A अगर 1 हुआ तो 100 डिवाइडेड बाय 101 तो 1 हुआ ना, 100 थोड़ी हुआ. 10,000, a huge number. 1 लाख, 1 मिलियन. Right? So let us say it is 10,000 जैसे आप कह रहे हो या whatever. Now, can we use this 10,000 here and get a really large signal to noise ratio? Can I use this A to be 10,000? भाई सिग्नल टू नॉइज रेशियो अब हमारा A है, अब ने यहां 10,000 काम में ले लिया A और we got 10,000 signal to noise ratio. Can I use 10,000 on the left hand side and get the same signal to noise ratio? कर सकता हूं मैं? क्यों? Pardon?
Equation of gain is different.
Equation of gain is different and here is feedback included.
Yes.
No feedback.
पर दोनों में ए है ना भाई, सिग्नल टू नॉइज रेशियो दोनों में ए है. Yeah, but why can't I use gain 10,000 here? आप सब सोचे नहीं, आपको तो I cannot use that huge gain in open loop. कभी आपने op amp चलाया है open loop में? It will either go to plus 15 or minus 15. You cannot run. As a matter of fact, जो op amp का आपको gain देते हैं, that is never there. वो कहेगा 1 लाख है, पर 1 लाख नहीं होता. It could be any number. वो तो just आपको वो कहते हैं. Because they know that you cannot operate it in open loop. So now the thing which changed the world is you have got a device with the gain 10,000 or 100,000 or something like that. You cannot use it in open loop. That gain is of no use to you. You are throwing away that gain to increase your signal to noise ratio. यहाँ 1 लाख का है, यहाँ 100 का है, which is also quite high by the way. So your signal to noise ratio is 1 lakh here, 100 here. So it is 100 times more. No, 10,000 times more, 10,000 times more. And you have thrown away a gain you are not going to use. That is the first insight into electrical engineering. That why amplification is important. Amplification is allowing you to set up a feedback loop where you can throw away things you don't want. Same way with non-linearity, same way with many things. Feedback lets you do because of this high gain. 10,000, 1 lakh. Those amplifiers are available to you. Op amp कितने का आता है? 20 रुपए, 30 रुपए का, right? No cost. ट्रांजिस्टर जितने में op amp आ जाता है आजकल. Right? So this is the backbone of electrical engineering. This type of feedback. Unless we understand that, we are not getting into the feedback theory. So आप अब अगर घर जाकर आज देख लेना कि same idea applies for non-linear distortion. Okay? And there are many harmonic distortions and there are so many things it applies, the same idea. So unless you think in practical terms, आपको उसका you will not get the hang of it because A and A both the places are same. What are you going to do? It does not tell you much. But when you get into it, when you get the numbers going, so the first fundamental principle is that feedback helps us do many things because of the gain we have no use for. जो op amp का 1 million का gain है, you have no use for that gain unless you put it in a feedback. तो आप ये सोचो कि people who developed this, they must have had really brilliant insights into the whole issue. वो insight you have to carry when you are doing research. That what is it we are going to achieve at what cost? I mean, cost is high here. You have got a gain of 100,000 and you are getting only a gain of 100. So you are throwing away that much gain. But that gain was no use to you. आप उसका कुछ नहीं कर सकते थे. And that's why it is such a brilliant thing. If you have to trade off with things which you could do, then it will be a really difficult issue. Okay, so ये पहली चीज. फिर दूसरी चीज. I operate this. I get a simple transistor. Make an amplifier out of it. RC or RE or whatever formula is there. And I run it. Most likely it will not go unstable. It will run all right. What can we say about that? What just happens when I go there? What happens? On the right hand side, what happens when I have that right hand configuration, when I connect it in practice? What happens? अपन ने कर तो दिया ये, that idea was brilliant, but what was required to get that idea working? That's the other half of electrical engineering. What are the key ideas to get that guy working? क्या आपको उसमें कोई तकलीफ दिक्कत दिख रही है? That one, to get it working practically, आपको कोई तकलीफ दिख रही है कि यार this might cause a problem, this may not cause a problem. When you are designing feedback controllers, what is your biggest worry? Stability. As soon as you connect something in feedback, stability is an issue. Right? You can't, so that's why we are in business. नहीं तो हमारे जैसे लोग घर पे बैठ जाते हैं. अगर स्टेबिलिटी इश्यू नहीं होता तो हमारे जैसे लोग घर पे बैठ जाते. Right? So it becomes unstable. Now that is another insight. Unstable क्यों होता है? Instability कैसे? How is instability generated? क्योंकि इतने दुनिया में 1000 पेपर्स है, 1000 थिंग्स है, वो है, और इंस्टेबिलिटी. सो अगर आपके पास एक डोमिनेंट आइडिया है कि इंस्टेबिलिटी क्यों होती है, सो यू कैन स्टार्ट फॉलोइंग ऑल दैट लिटरेचर, एवरीथिंग, एंड यू कैन स्टार्ट अंडरस्टैंडिंग व्हाई पीपल आर डूइंग सो मेनी डिफरेंट थिंग्स टू डिजाइन कंट्रोलर्स. अगर आपको ये नोशन है कि इंस्टेबिलिटी क्यों होती है, जैसे अभी आपने देखा कि प्रैक्टिकली, आई होप आई हैव कन्विंस्ड यू दैट दिस इज a practical issue, and how, what a wonderful solution has been provided to us. Practical इसमें जिसको ट्रांजिस्टर ऑपरेशन, ऑप एम्प ऑपरेशन जिसको मालूम था, I mean they didn't have op amps, maybe in 20s they didn't have op amps, 20s 30s, I don't think so. So they had transistors with very high vacuum tubes, but with still very high gain. You can cascade them together and get very high gain, no doubt. I am not quite sure when differential amplifier came, honestly, but yeah, वो उसमें ट्यूब के टाइम में भी differential amplifier था. So something very practical has helped us achieve some extraordinary results. Now, to implement those results, they again got stuck. ये ब्लेक साहब ने ये प्रपोज तो कर दिया, but they again got stuck. How to implement it? So what problems do you anticipate in implementing it? Sir, in the black t-shirt. क्या आप बताएं? What problems do you anticipate in implementing it? Or why do you think instability is caused? देखो, आप जो मैं कह रहा हूं, आपके मन में जो आए वो बोले, because many times what happens is the way I am asking is different. Maybe you know the answer, but जैसे मैं पूछता हूं, you can't answer me in that same way, but you have got some ideas as to why things become unstable. चीजें क्यों अनस्टेबल होती हैं in a feedback configuration? नहीं तो सभी फीडबैक लगाकर घूमे, क्यों तकलीफ में वहां गया, कैसे उसने अनस्टेबल हो गया, वो क्यों होता है? Instability, yes ma'am?
Output goes unbounded.
Yeah, that is the consequence of it.
But location of port.
The input तो आपका ठीक ठाक है.
Because in open loop system we cannot control the output because it may be larger. In case of closed loop system with the help of feedback we can have controllable output.
मतलब आपके दिमाग में वो मैं समझ नहीं पा रहा हूँ, but maybe what you are saying, you understand what you have in your mind. But now the question is, why do things become unstable?
If we cannot control the output, we can say that the system is likely to be more unstable.
See, ये लीनियर सिस्टम है, उसमें it is not dependent on input and output. It depends on the property of the system. Error, ये आपकी बात सही है, error है, very good, that's a good starting point. So this error, so what is, very good, very good. So what is about that error? Pardon? या एरर है, आप क्या कर रहे हैं, आप मेरे को उसके कॉन्सिक्वेंसेस बता रहे हैं. You are right, but you can still think of error. What is it about a system which makes it unstable? Well, आपने you said improper synchronization. उसका कोई generic improper synchronization means ये दोनों का कुछ problem है. That's what you mean, right? Good. That's a good answer.
Due to disturbance of the signal.
आपकी बात सही, but let me clarify one point which I have to clarify again and again. This is a linear system, so everything is property of the system itself. It does not depend on the property of the input, output, noise, this, that. It is inherent to the system. आपकी बात सही है. Synchronization, very good way of, हर का अपना तरीका होता है to look at it. So what could it, we can say in a general term. If they are not synchronizing, what does it mean? आप ही करें, just think bit more. If they are not synchronizing, आपने कहा कि दोनों, the out,
They should be both should be equal and
नहीं इक्वल तो नहीं होने चाहिए क्योंकि एरर है वो होता है. सिंक्रोनाइज नहीं कर रहे उसका मतलब क्या? जैसे यू हैव सेड अ वेरी नाइस थिंग, आई थिंक यू हैव पुट इट वेरी नाइसली. जैसे ये ऐसे है एस आई और एस आउट सपोज ऐसे है और वॉट एवर. यस, lagging, right? If they are not synchronizing means they are lagging. Can it lead?
Can be leading or lagging.
Leading. आपने कौन सा सिस्टम देखा जहां लीड करते हैं? पढ़े? लीड किससे करेगा वो? देखो भगवान ने दुनिया ऐसी बनाई है. न्यूटन का लॉ क्या है? फोर्स इक्वल्स टू मास टाइम्स एक्सेलरेशन, राइट? सो पोजीशन विल ऑलवेज लैग द फोर्स. भगवान ने दुनिया ऐसी बनाई है कि लीडिंग एलिमेंट्स है ही नहीं, सब इनर्शिया से भरी है दुनिया. कैपेसिटर दैट कैन डू लीडिंग, बट भगवान ने दुनिया कुछ ऐसी बनाई है कि वेन एवर देयर इज अ फिजिकल सिस्टम, यू अप्लाई अ फोर्स, द आउटपुट कम्स आफ्टर अ वाइल. ये दुनिया ऐसी बनी है. Because when you apply force, the position changes 2 integrators, 180 degrees phase shift, right? So your idea about not synchronizing, we say that there is a lag. Madam ne kaha lag, aapne kaha. So the delay, so technical word is delay. The delay caused by the signal is what troubles you. And what is the indicator of delay in our daily language? We have a word for delay. Just किसी ने कहा था अभी. In linear systems there is a word for delay. Phase lag. In linear system, in non-linear systems and time delay systems we use delay directly. But in linear systems, delay is said as phase lag. तो क्या थ्योरम है? What is the theorem which relates phase lag, gain and stability? कितने phase lag के बाद तकलीफ होना शुरू होता है? कितना phase lag है उसके बाद तकलीफ होना शुरू होता है? Suppose I have got a first order system, right? Force equals to I'm relating force to velocity. Okay, so कितना lag होगा? if I am not wrong, something like that. तो फोर्स और वेलोसिटी में कितना लैग है? 90 डिग्री और पोजीशन में 180. सो कितना लैग होता है तब आपको तकलीफ शुरू होती है? Pardon? 45 तो एकदम रॉक सॉलिड गेन है. उसमें आपको तकलीफ हो ही नहीं सकती. तो फेज मार्जिन आप अलग बात कर रहे हैं ना. यू आर टॉकिंग अबाउट समथिंग देयर. सो व्हाट इज द फेज लैग वेयर यू स्टार्ट टू बॉदर कि यार अब समस्या होगी? 180, राइट? आपका फेज मार्जिन वगैरह का रिजल्ट इट इज ऑल 180 रिलेटेड, राइट? हाउ मच फार यू आर फ्रॉम 180, दैट्स फेज मार्जिन, राइट? कि आप कितने दूर हैं. सो 180 इज वी आर ट्राइंग टू गेट इनटू डिफिकल्टी. और थ्योरम क्या है? व्हेन द फेज इज 180, व्हाट शुड बी द गेन फॉर स्टेबिलिटी? या शुड बी less than 1. आपका ठीक है कि it is critical stable when it is 1. So gain should be less than 1. Right? So the gain and phase are related. If अगर आपका phase lag 180 है और यहां तो आपका gain you are talking about 1 लाख, यहां gain आपका 10,000 है. A beta gain is 10,000. आप एक पे परेशान है, यहां 10,000 है. राइट? यहां 10,000 है. सो हाउ? सो दिस इज द थिंग. सो नेक्स्ट थिंग आई वांटेड टू टॉक वाज फ्रीक्वेंसी डोमेन मेथड. सो व्हाट आई एम ट्राइंग टू गेट इज, बिफोर these methods came, how would you, if you did not use frequency domain results to check the stability, how else would you do that? Pardon? Very good. And what is that in practical terms? What does that mean? What does Routh-Hurwitz criteria do?
It says that all the poles must be in the right half.
ये Routh-Hurwitz criteria नहीं है. राइट Hurwitz criteria बताता है कि कब ऐसा होता है.
Number of sign changes.
ये तो वो बताता है. पर you check for the poles in the right hand side. So all the poles should be in the left hand side. So how would you check that given the representative? Suppose before we came to frequency domain, how did you represent these systems? Pardon? Transfer function तो मैं frequency domain हो गया ना. But you get the frequency transfer function using some other thing, right? So what is that you start with? Yeah, root. Pardon? नहीं, उसके पहले the equations are in which form? State variable, sir. So they are differential equations, right? So what you do is, you take a differential equation. So differential equation you take. Okay, you got differential equations. And what is the term called when you want to solve the differential equation? What are those things called? Differential equation का solution कैसे होता है? दुनिया की सारी डिफरेंशियल इक्वेशन लीनियर का सॉल्यूशन एक ही है. लीनियर डिफरेंशियल इक्वेशन का दो नहीं, एक. एंड लैम्डा डिपेंड्स ऑन योर सिस्टम, राइट? व्हाट डू वी कॉल दैट लैम्डा? आइगन वैल्यू. एंड हाउ डू वी कैलकुलेट आइगन वैल्यूज? गिवन अ डिफरेंशियल इक्वेशन, हाउ वुड यू कैलकुलेट आइगन वैल्यूज? बाय सॉल्विंग. यस, थैंक्स. By solving which equation? Characteristic equation, eigen equation, correct. Yeah, so you solve that equation, so you can do that, and so you have got k1 e to the power lambda 1t, right? एक solution ऐसे होता है. Correct? So if there is an nth order differential equation, you will get n eigenvalues. And stability के लिए क्या जरूरी है? All these eigenvalues should be, where should they be? Left side of the left half plane, right? So if you want to check the stability of this thing, how do you do that? You write the characteristic equation or differential equation, get the characteristic equation, solve for the eigenvalues, and make sure that every single eigenvalue is in the left half plane. ये तो आपने किया. Now, when they sat down to write this equation, what was the order of that equation? Pardon?
Highest power of that equation.
Yeah, what was that? आपने एम्पलीफायर है, आपने एम्पलीफायर डिजाइन किया, आप बैठे हैं एम्पलीफायर के सामने, और क्या ऑर्डर होगा उस इक्वेशन का? वेरी गुड, ब्रिलियंट सर. तो कितने एनर्जी स्टोरेज एलिमेंट थे? Good starting point. Anybody else? Yeah, you are 100% right. Energy storage element. Perfect. No doubt. पर कितने थे? When they sat down in front of that amplifier, they counted energy storage element. जैसे आप कह रहे हैं, exactly they did that process. आपने कभी एम्पलीफायर देखे? मैं भी यहाँ होगा कहीं हिस्टोरिक पर्पस नहीं है, ट्यूब एम्पलीफायर नहीं है. ये काफी डिपार्टमेंट में भी आईआईटीज वगैरह रखते हैं फॉर हिस्टोरिक पर्पस एम्पलीफायर्स. सो टू आपने कहा दैट वुड हैव बीन अ ड्रीम. सो नाइक्विस्ट सेज दैट इट वाज 67th ऑर्डर. ये नाइक्विस्ट का स्टेटमेंट है कि वी काउंटेड बिकॉज दे वांटेड टू फाइंड आउट व्हेन दिस सिस्टम विल बी स्टेबल. बिकॉज जब ब्लेक ने कहा कि ये करो, एंड व्हेन दे वेंट टू डू दैट, things don't work. It was all going unstable. Right? So Nyquist ने कहा how many? 67th order. और तब तो slide rule थे, calculator नहीं था आपका. So to take an equation and find out 67 roots of the equation. And then when you change A and beta, what do you need to do? So एक आपने किया, you found one root on the right hand side, काम खत्म. You have to choose another A and beta. Choose another again. Could they have ever come to the end of the process? नहीं. So what did they do? They came up with frequency domain answers. So what is the frequency domain thing? Can somebody summarize it? अपन ने discuss किया था. So if I want to find out, okay, if I want to find out that this system is stable, what do I do? Using frequency domain tools, what do? I have got this system. I want to find out whether it's stable or not. What do? ये आधी इलेक्ट्रिकल इंजीनियरिंग है. एंड वंस यू पुट द टू थिंग्स टुगेदर, यस, बोडे प्लॉट, गुड. सो बोडे प्लॉट, चलो आपने पहली बात की, आपकी पहली बात मान ली, बोडे प्लॉट. उसके बाद क्या करें? किसका बोडे प्लॉट बनाना है? किस चीज का बोडे प्लॉट बनाना है? कौन सा ट्रांसफर फंक्शन बताएं? कौन सा? let me write this here. Let's make it simple now. Right? ट्रांसफर फंक्शन हो गया आपका. बोडे प्लॉट किसका करना है? बोडे प्लॉट बनाना तो है, नागपुर का करना है, दिल्ली का करना है, बंबई का करना है. किसका बनाना है बोडे प्लॉट? यस सर. A beta. Very good, sir. Very good. Thank you. Now what do I do? अब कैसे मैं पता लगाऊं कि when I close the loop it will be stable? या क्या है वो बताएं? नाइक्विस्ट छोड़ो, आप मोडे का ही बता दो। नाइक्विस्ट तो बहुत बड़ी बात होगी।
First make that magnitude plot, then phase angle plot.
या वो तो बॉडी प्लॉट में आ गया, ठीक है, हाँ, फिर क्या करूं मैं? आप लोग एकदम जो क्लास में सिखाया वो बोल रहे हैं, एंड दिस इज राइट, व्हाट यू आर सेइंग इज राइट, आई एम नॉट सेइंग व्हाट इट इज, बट व्हाट डू यू डू प्रैक्टिकली? यू फाइंड आउट राइट, ये झंझट करते हैं। वी फाइंड आउट दैट फ्रीक्वेंसी फॉर विच द फेज शिफ्ट इज -180, फाइंड द गेन एट दैट फ्रीक्वेंसी, एंड इफ द गेन इज लेस देन 1 वी आर स्टेबल, राइट? ठीक है, एंड गेन मार्जिन, फेज मार्जिन follows from there. Okay, so how do we get AS? How do we get, so ये AS or AJ omega, how do we get that? आपको किसी ने ट्रांसफॉर्म वो एम्पलीफायर दे दिया और आपको उन्होंने कहा हमको AS या AJ ओमेगा ला कर दो, तो आप कैसे लाएंगे? राइट, आप लैब में गए और मैं आया आपकी लैब में कि मेरे को कंट्रोल का, भाई ये कंट्रोल के एक्सपर्ट आए, तो मैं तो आके सीधा पूछूंगा, भाई मेरे को AS दो, आपको कंट्रोलर मेरे से बनवाना है तो AS दो मेरे को, राइट? सो आप कैसे AS कहां से ढूंढ के लाएंगे? आपको एम्पलीफायर दिया, जिस चीज का AS चाहिए वो आपके सामने पड़ा है। Very good, very good. So get state space, then AS equals to क्या है वो, D plus SI minus A all inverse, या कुछ ऐसा है ना, CB कुछ ऐसा है, right? Is that what you meant, sir? तो उसके लिए पहले हमको स्टेट स्पेस चाहिए ना। आपको अगर मैं कोई एम्पलीफायर बिठा दूं सामने तो स्टेट स्पेस निकालने में कितनी तकलीफ होगी? होगी कि नहीं होगी? होगी कि नहीं होगी? Has anybody done this in their professional life to get a state space representation of a system? कैसे आप लाओगे? जब मैं आपकी लैब में आऊं, आप कहो मैं ये कंट्रोलर मेरे को डिजाइन करना है, मैं कहूँ भाई मेरे को AS तो दो, कम से कम ट्रांसफर फंक्शन तो दो। आप कहोगे मेरे को वेट, मैं अभी स्टेट स्पेस डिफरेंशियल इक्वेशन लिखता हूँ, फिर स्टेट स्पेस बनाता हूँ, फिर आपको दूंगा। तो मैं कहूँगा 2 साल बाद आऊँगा। आपको 2 साल बाद मिलेंगे, तब तक आप स्टेट स्पेस ढूंढ के लाएं। You can do that if you know the physics of the problem. You can do that. People do it all the time. Every day they do it. But how they do it is our main issue. Correct? चलो आपको ट्रांसफर फंक्शन छोड़ा, I only want AJ ओमेगा। मैंने कहा यार अपनी दोस्ती अच्छी है, आपको कम, I'll give you a smaller problem. AJ ओमेगा दे दो, मैं इससे काम चला लूंगा। How would you find AJ ओमेगा? ये सबसे पावरफुल रिसर्च टूल है आपके पास. हाउ वुड यू फाइंड AJ ओमेगा? एनीबडी? कैसे? मैंने आपको एम्पलीफायर के सामने बिठा दिया या जो भी सिस्टम है उसके सामने बिठा दिया, या आपने मेरे को बुलाया कि मेरे को कंट्रोलर डिजाइन करना है, तो क्या AJ ओमेगा कैसे पता लगेगा? मतलब कौन क्या बोले? जोर से बोले. फ्रीक्वेंसी. या बताइए क्या करेंगे? यस, व्हाट विल यू डू? प्लीज हेल्प अस आउट विद दैट. फ्रीक्वेंसी आपने सही बात कही, गलत नहीं गई. This is the first things in electrical engineers need to know. सबसे पावरफुल टूल आपके पास है, पर आपने उसको इस्तेमाल करना कभी सीखा ही नहीं. आपका स्मार्टफोन है, पर आप उसको नोकिया की तरह चला रहे हो. तो इलेक्ट्रिकल इंजीनियर का ब्रेड एंड बटर काम है ये. कैसे करते हैं? यस मैडम, एनी आइडिया? हम बोले फुल. या आप, यू आर राइट, दैट्स व्हाट आई सेड, यू आर राइट. सो क्या करते हैं, कैसे? आई एम सिटिंग इन अ लैब, रिमेंबर, आई गॉट ऑल द इक्विपमेंट. अभी वो अपने कौन केसरी सर आए थे, तो इक्विपमेंट ही वाज शोइंग. मेरे पास वो इक्विपमेंट नहीं है. फटाफट वो वीडियो बता रहे थे. उनके पास और आपके पास जो इक्विपमेंट है वो मेरे पास नहीं है. यू हैव गॉट यूज ऑफ ऑल दैट इक्विपमेंट. अब मेरे को बताओ कैसे करूंगा मैं? ये तो एकदम मतलब इतना पावरफुल टूल है. एंड डोंट फील बैड अबाउट, और मे बी यू नो, जैसे मैं पूछ रहा हूं आप बता नहीं पा रहे, ये भी संभव है कि जिस प्रकार मैं पूछ रहा हूं आप बता नहीं पा रहे, यू नो द आंसर. Pardon? Yeah. Good. Very good. Very good. AI पर क्या करना पड़ेगा? AI ऐसा थोड़ी कैसे तो सामने कि AI ओम नमः शिवाय, ओम नमः शिवाय, AI वो थोड़ी आंसर दे देगा. उसको कुछ करना पड़ेगा ना. क्या करोगे आप? आपको एम्पलीफायर दे दिया, इनपुट यहां है, आउटपुट यहां है, और आपके केसरी सर के लैब के सारे इंस्ट्रूमेंट्स आपको दे दिए कि ले लो ये इंस्ट्रूमेंट्स, कि जो हिमांशु पोटा के पास भी नहीं है. क्या करोगे आप? AI या AI, यू कैन यूज एनी टूल यू लाइक, पर AI में भी कुछ तो करना पड़ेगा ना. कोई चीज कहीं जोड़नी पड़ेगी. मैं टाइम इसलिए ले रहा हूं इसमें क्योंकि ये मेरे को इससे ज्यादा कुछ नहीं आता. मेरे को इतना ही आता है बस, पर वो ठीक से आता है क्योंकि मैंने कंट्रोलर बहुत डिजाइन किए. एटॉमिक फोर्स माइक्रोस्कोप का भी क्या, जो नैनोमीटर वो वाइब्रेशन होते हैं, इट वेरी सक्सेसफुली. और यही आइडिया जो अपन डिस्कस कर रहे हैं एग्जैक्टली से, उससे ज्यादा मेरे को कुछ नहीं आता. इसीलिए मैं वो एम्फेसाइज कर रहा हूं कि टू गेट यू टू सी द वे आई लुक एट इट. आपके अपने पर्सपेक्टिव होंगे, दे आर वेरी गुड, वैलिड, यू आर ऑल वेरी सक्सेसफुल पीपल, नहीं तो आप यहां बैठे नहीं होते, राइट? But I'm just trying to have you to see it slightly differently the way I look at it. तो कैसे करेंगे? फ्रीक्वेंसी कहा किसी ने? सबसे पावरफुल टूल अपने पास है, वेरी सिंपल, सबसे पावरफुल टूल. केसरी सर को जाकर आप परेशान करना कि हमको वो चाहिए, हैं? उनके पास है वो टूल. अब कुछ, कैन यू रिकलेक्ट समथिंग? यस मैडम बोले.
Giving signals of different frequencies as input and observing the output of.
यस, तो कैसे अब मैं ए लिखूंगा उसमें? क्या करना है? सपोज मेरे पास ये इनपुट है एस आई Okay, मेरे पास sorry, I'm sorry. Suppose मेरे पास से input है V sin omega t, Vi sin omega t. What will output look like? क्या equation?
Then should be a sign wave, maybe change in magnitude and maybe change.
Did you mean that? Can you find that out by displaying that on oscilloscope? And you do that for? What do? You do it for one, then you do it for?
Change the frequencies and
Keep doing, keep doing, keep doing, keep doing, keep doing. Do it 100 times, do it 200 times, do it 300 times. आपको आधा घंटा लगेगा, 25 मिनट लगेंगे, क्या टाइम लगेगा? और अब तो ये सब टूल्स है, they will do it automatically for you. You keep changing the input frequency, sine sweep इसको बोलते हैं. You do that, you get the output, it will take the phase difference, it will take the magnitude difference, and you, आपका Bode plot will be ये आपका Bode plot हो गया. For every sine wave you will get two numbers, V out and V in, and phase phi. आधा घंटे में हो गया. जब मैं अगर आपके ऑफिस में आऊं, आपकी लैब में आऊं, आपके बाद चाय पी कर आओ यार, एंड यू आर डन. This is a very, very powerful technique. We use it every day. And this is what changed everything. If you had to do this state space and all that you'll never see the end of it. Or furthermore, you can directly design controllers from the Bode plot. Directly, graphical, complete graphical design. You never have to do state space. But you do state space for some reasons and whatnot. Right? And these are the two ideas which completely change electrical engineering. Firstly, the feedback and the gain you never needed, and this extremely high gain situation where you can become unstable like that. If you went the differential equations and all that, never, you could have never come to that. What happens if you change the gain of Bode plot, in Bode plot? Up or down? Simple. So you know how much DC gain you need for closed loop stability. उसको नीचे ऊंचा DC gain से होता है. अगर gain instead of 1 it is 10, what will you do? You will apply a DC gain of 1 on 10. सबको नीचे ले आओ. Yeah, there are many other things you can do. You don't even have to do anything, just look at it and you got your answer. ये सबसे powerful tool है. It is a very powerful idea when you look at things, why they go unstable, what not. Firstly, what is the delay? What is the phase delay? What is the delay? Is there an element causing delay? जो आप इन्वर्टर वगैरह इन्वर्टर्स वगैरह करते हैं आप, so most of the times how do you model an inverter in your power system simulation? आप इन्वर्टर यूज करते हैं? How do you model it in your power system simulations or calculations? जैसे आप पावर सिस्टम का काम कर रहे हैं, how would you model it? Most of the times you model it as constant gain. Because it is, the delay there is so small. You are talking about kilohertz and megahertz and all that business. और पावर सिस्टम में सब कितना धीरे धीरे चलता है. पावर सिस्टम में सब धीरे धीरे चलता है. So those are the ideas which will help you look at the thing practically. Whatever we have been talking, think about it. And that is applicable overall. कि feedback किया है? Why have you done feedback? क्या कारण है feedback का क्या? What is the purpose of doing feedback? First you have to ask the question. जैसे अभी यहां पर ने पूछा फीडबैक हुआ, उससे क्या लाभ हुआ, व्हाट डिड यू गेन आउट ऑफ फीडबैक. Secondly, what are the delays in the system? Thirdly, how can I model the system easily? मतलब कितने ऐसे पेपर होते हैं जहां मॉडल होता ही नहीं है सिस्टम का, चल रहा है धनाधन उसने कंट्रोलर डिजाइन किया, ये कर दिया, बट हाउ एम आई टू इवेल्युएट इफ द कंट्रोलर इज प्रॉपर और नॉट? वो कहेगा कि आप सिमुलेशन करके देखो. अरे भाई मैं कहां सिमुलेशन करूंगा? आई शुड हैव सम आइडिया अबाउट द मॉडल, सम आइडिया अबाउट हाउ इट इज वर्किंग. Right? And all this is, so what is essential for this is, the overriding thing is linearity. And आपके जो inverters वगैरह हैं, they are not linear as such. So we have to do their linear range and all that. We can do lot of analysis working in the linear range. बहुत होता है analysis linear range में काम करने के. Your linear range gives you this great ability to model things in a practical way. और ये बहुत बड़ा idea है. But that changed the complete electrical engineering. Two things. Feedback is good, but how to make it as stable? Big question. To make it stable, you need models for it. Using physics-based models is very difficult. So we use frequency models. Why do we use frequency models? Because we can measure it. दिमाग की जरूरत नहीं है उसमें, आपके AI की जरूरत है. दिमाग की जरूरत नहीं है उसमें, लगाया, ये किया, फ्रीक्वेंसी शिफ्ट किया, गेन किया, and you are done. And once you have that, then the world is your stage. मैटलैब में लगा दो उसको, तो आप क्या से क्या कर लो. पर मैटलैब को भी ये चाहिए ना, मैटलैब को ये चाहिए. ये इंफॉर्मेशन अगर आपने दे दी मैटलैब को तो यू आर किंग. आपको कुछ और, दिस इज अ वेरी फंडामेंटल आइडिया आई वांट टू गेट अक्रॉस टू यू. आप थोड़ा सोचें इसके बारे में जाकर. आप इलेक्ट्रॉनिक्स की किताब या ये यहाँ कंट्रोल की किताब ये देखेंगे, व्हाई फीडबैक इज यूज्ड, अगेन यू रीड इट. फीडबैक क्यों काम में लेते हैं, ये बहुत बड़ा आइडिया है कि कब काम में लेना चाहिए, क्यों काम में लेना चाहिए.
Measurement, here we are measuring, measurement, then comparing, getting error, and then correction.
Correct. Yeah, that's right. So इसमें you are correcting. So that's right. So for this to be small, error to be small, what is essential? Now we look at it a slightly different way. सर ने जैसे कहा कि अपन मेजरमेंट करते हैं, एरर लाते हैं. For feedback to work well, our error should be zero, very small. If error has to be zero, what can we say about A? A क्या होना चाहिए? अरे 1 नहीं, अगर 1 होगा तो आपका आउटपुट भी छोटा होगा ना, वेरी हाई. You have to say something. That's very essential. आपने 1 कहा और अभी आंसर है 100, तो आपको हमेशा याद रहेगा. जिसने 1 भी नहीं कहा उसको तो 100 भी याद नहीं रहेगा. गलत सलत, it does not, in this world गलत सलत का कोई जगह ही नहीं है. It is just what you start with and where you end. You can see now कि गेन बहुत हाई चाहिएगा, राइट? तो हाई गेन इज एन एसेंशियल क्वालिटी फॉर फीडबैक. और हाई गेन से क्या तकलीफ होती है? हाई गेन है, अपन ने इतना देखा, हाई गेन से क्या, ये क्या कह रहा है? गेन 1 से कम होना चाहिए. अगर हाई गेन लगाएंगे तो अनस्टेबल हो जाएगा. तो ये देयर इज ऑलवेज अ ट्रेड ऑफ. आपको एरर कम चाहिए तो गेन खूब लगाना पड़ेगा, और गेन खूब लगाओगे तो इनस्टेबिलिटी आ जाएगी. तो सारा खेल उसी का है. टू कैच इनस्टेबिलिटी, कीप द सिस्टम स्टेबल एंड कीप गोइंग दैट वे. ठीक है, इससे ज्यादा मेरे को कुछ नहीं आता. मैंने सब कहा, आप नारियल देकर भेजना तो भेज दो. I don't know anything more than that. Okay. अब अपने को what's the time? So how are we doing with time? We break लेना? हाँ. Break because we are at a point. We'll take up the next thing as we come. Okay. Thank you very much, sir.
Blank వస్తుంది. ये क्या अब तो आंसर ऐसे बोल रहे हैं. अब तो साल हो रहे हैं हम लोग. हमको तो नहीं पता. रोल की साइड देख लो एक बार. इस साइड से नहीं है ना.
యూట్యూబ్లో పంపిస్తాను. యూట్యూబ్లో నేను కూడా పంపిస్తాను స్టేజ్ మీద చూపిస్తున్నాను. అందులో మార్చుకోలేదు. సార్
हाँ जी सर को बताएं तुम्हारा पीसी है ना उसका वाला वहीं बैठे बैठे हो जाता
मेरा पीसी
हाँ सर
हाँ ठीक है.
नंबर इज लेस
पता नहीं सर. हाँ ठीक है.
वन फैमिली स्टिल लेस
हाँ कर
ट्रिगर
So much more than you have to teach. Now, what to teach is very difficult. So unless you got practical experience, you do not know what to focus on. जो मैंने पढ़ाया, that people just board plot के what the transfer function is, one state space transfer function, but they do not understand why they have done it. कैसे बूढ़े प्लॉट क्या है, इसका मतलब इतना नहीं है. अब ये बूढ़े प्लॉट ओपन लूप का होता है, कितने लोग क्लोज लूप का लगा देते. So all these things, unless you have designed it, आपने कोई practical काम किया है, then you 100% sure that this is important.
Sir, we lag in that.
So because I have designed so many components, I know what is important. But the subsidiary secondary, these are the important things to start with. Everything, all those things are important. But unless you start the right way, you will not understand the big things why they are important.
We mostly focus on big things rather than the small.
Yes, इसी में सब है. Because big things so you can follow. If somebody, unless somebody tells you these small things, how would you know they are important? How would you know that this simple thing is so important? आपने किया हुआ एग्जाम में आता है तो आपने कर दिया. So anyway, I mean, I just wanted to share my experience, and these are very important things. No matter the paper you are reading, what you are doing, if you apply these basic common sense questions, you understand more out of it. If the paper is nonsense, you immediately pick up. It will waste of your time. Because you have not looked at the things the right way. They take my third X and apply the problem Y, that is not what you want to do. So what you want to read those papers where they understood the problem well, they designed a method applicable to the problem. So you apply this few basic common sense tests and you move. Otherwise, the so vast. हजारों लाखों पेपर्स, हजारों बुक्स हैं. What do you need? What do you focus on? Okay, sir. शुरू. slide it, leave it like that. Yeah, this is perfect.
हाँ सर लाइक अभी ये तो छोटा दिखेगा उनको लाइक लाइव स्ट्रीम में ऐसा आएगा आप ये बता दीजिए लाइक वी कैन स्वैप द स्क्रीन इफ यू वांट
Yeah, now we can maybe stop the screens and then we can go back. मैं आपको request करूँगा. Let's go back to the this thing
हाँ सर
and then we can have that.
हाँ सर हाँ डे 3 का है सर 2 तारीख को लीकेज करंट का तो ये भी है SHC हाँ सर कर सकते हैं हाँ हो सर उसमें FFT अभी तो कुछ करना है सर टाइम मैं अभी जाके देख लेता हूँ नहीं तो मॉडल तो हो गया मैं उनको दिखा सकता हूँ कि वो एक हम अल्फा वेरी कर रहे तो मीन वैल्यू कैसे वेरी कर रहे हैं वो स्कोप में दिखा सकते हैं उसका एफ क्या है वो हाँ सर वो कंपेयर मॉडलिंग कर रहे हैं हाँ हाँ yes sir वो भी सही है
Thanks. See, whatever I am saying, I am assuming कि आपको पावर सिस्टम से कुछ लेना देना होगा. Is that a right assumption? Yeah. Or how are these things related to power system? We will see. See, these things are everywhere. What we discussed just now, they are everywhere. Okay. Explicitly how they are there, we can see as we go. And some of the things I'll cover in this 5 days, they are not explicit, right? But still we will learn some fundamentals, or we will look at something fundamental things, which we also need to do, and this sits on top of it. Okay? So when you are doing research, when you are thinking about power systems, when you are thinking about these solutions, if you have these ideas in your mind, it will work out to be very well. Now, कहाँ गया अपना वो slide? Sorry. तो पहले दोनों अपन ने कवर कर लिए, वाई फीडबैक, वाई फ्रीक्वेंसी रिस्पॉन्स मेथड. सो अब ये सिंक्रोनस मशीन, नाउ आप सब कहेंगे कि वी आर गेटिंग रिड ऑफ सिंक्रोनस मशीन्स, राइट? And we are coming to renewable, and all renewable now, solar, wind, and this and that. So why should we even worry about synchronous machines? कोई मेरे को बता सकता है कि why do you think, or should I not worry about synchronous machines at all? क्या कारण है synchronous machines को के बारे में सोचने का? Is there any reason for us to worry about synchronous machines when we are changing over everything to renewable? Yes? Inertia, that's right. Inertia, you mean to inertia in the system, ke it will take a while to retire all the synchronous machines. That's what you meant, right? That is true. Other reason is, the way I look at it is, this system was designed for synchronous machine, right? The system was designed for synchronous machine. Many of the control methods, many of the things we use have been based on synchronous machine operation, right? So synchronous machine is not just a machine. So when you got an interconnected power system, right? Like in India, you got this grid, that grid, and you connect it using HVDC and things like that. So any grid you take, say Maharashtra grid you take, right? What is it? How do you look at it? What does it mean to you? Dynamically speaking, क्या उसका मतलब है? क्या हो रहा है वहां? ग्रिड में क्या हो रहा है? So what is the most fundamental aspect of any grid? Why do we have grids? Yes? Pardon? Load. Very good. आप पूरा सेंटेंस बोले. हिंदी में बोले, मराठी मेरे को थोड़ी कम समझ आती है, पर मराठी में बोल दे. ये मकरंद जी और प्रोफेसर कुलकर्णी ट्रांसलेट कर देंगे. पूरा सेंटेंस बोले. हाँ, लोड. वेरी गुड. फिर उसके बाद जोर से सर. लोड विथ जनरेशन. सो दैट इज, ये किस्सा इसका है. आपने आधा बोला, सर ने पूरा बोल दिया. So generation and load have to be meshed, right? If they are not meshed, what happens? Suppose we have got all solar generators. Forget about synchronous machine. अगर generation and load are not meshed, जो थोड़े बादल आ गए और आपका जनरेशन थोड़ा रिड्यूस कर गया 5%, 10%, तो क्या होगा? कैसे अनस्टेबल होगा? मतलब कैसे? वही मैं समझना चाह रहा हूं. वोल्टेज क्या उसमें अनस्टेबल? क्या है? वोल्टेज थोड़ा कम हो जाएगा, ज्यादा हो जाएगा. अनस्टेबल क्या है उसमें? पावर, एंगल, क्या इश्यू होगा मेरे को बताएं. हाँ, वोल्टेज ड्रॉप होगा, उससे क्या तकलीफ हो जाएगी? हाँ, तो क्या तकलीफ हो जाएगी उसमें? यार इंक्रीज हो जाएंगे. चलो मान लिया कि बात, लॉसेस इंक्रीज हो गए. उससे बढ़ के क्या होगा? क्या होगा? सब इंस्टेबिलिटी कहते हैं, पर क्या होगा? फ्रीक्वेंसी क्यों ड्रॉप होगी? यार ये कमाल की बात कर दी आपने. मेरा सोलर सिस्टम, मेरे सोलर हैं खूब ढेर सारे लगे हैं, और कुलकर्णी साहब ने बड़ी फर्स्ट क्लास इन्वर्टर डिजाइन किए हैं. फ्रीक्वेंसी क्यों बदलेगी? बताएं मेरे को एक कारण. टेल मी अ रीजन व्हाई फ्रीक्वेंसी शुड चेंज. वोल्टेज में आपकी बात मान रहा हूं. व्हाई वुड फ्रीक्वेंसी चेंज? इसीलिए मैं कहता हूं आपको सिंक्रोनस मशीन सीखना जरूरी है, क्योंकि व्हाट यू आर टॉकिंग अबाउट इज नॉट रेलेवेंट टू दिस स्टोरी एट ऑल. But still it is relevant. It's not a totally irrelevant information. It is relevant. But we have to see how it is relevant. आपने सिंक्रोनस मशीन का आइडिया ले गया, यहां फेंक दिया. फ्रीक्वेंसी स्टेबिलिटी, अरे यार उसका क्या, हाउ वुड फ्रीक्वेंसी बी अ प्रॉब्लम? कुलकर्णी साहब ने इतना जोरदार इन्वर्टर डिजाइन किए, ये 50 हर्ट्ज पे ही डालता है. Why would it change from 50 to any other frequency? Am I making sense? So, a big problem in 5 days or in 5 years we have to sort out what will happen. ये किसी के पास जवाब नहीं है अभी. मैं ये नहीं कह रहा कि मेरे पास है और या किसी बहुत बड़े यूटिलिटीज के पास है, जो बड़े दिग्गज है उनके पास है, किसी के पास जवाब नहीं है. क्या होगा? This is a very, very important research question, very, very important practical question, very important question. What will happen? When you have got all wind, yes, wind में थोड़ा वो है, मशीन है आपके, वो रितेश जी खूब करते हैं उसका काम, राइट? तो उसमें थोड़ा है, पर सोलर में तो कुछ झंझट ही नहीं है. क्या होगा? आपका टीवी बंद हो जाएगा और क्या होगा? आपका रेगुलेटर वो क्या होगा क्या? ओके, सो अगर सिंक्रोनस मशीन है तो क्या होता है, राइट? मैंने आपको अभी का प्रॉब्लम बता दिया. तो सिंक्रोनस मशीन, आप लोग जो कह रहे थे, दैट वाज यू हैड इंप्रेशन फ्रॉम द सिंक्रोनस मशीन डोमेन. तो क्यों फ्रीक्वेंसी बदलता है जब सिंक्रोनस मशीन होती है? अरे सर, आपको तो आप यहाँ आ जाओ. तो मैं तो आपको फेवर कर रहा हूं, मैं पढ़ा रहा हूं, आपको मेहनत नहीं करवा रहा. आई वॉन्ट देम टू से, जब ये हैं, स्पीड रिड्यूसेस और इंक्रीजेस, या और डिमांड कम होगा तो स्पीड इंक्रीजेस, राइट? स्पीड चेंजेस बिकॉज ऑफ द डिफरेंस इन जनरेशन एंड डिमांड. सो अब ये तकलीफ ये है कि हर सिंक्रोनस मशीन का स्पीड एक ही जैसा बदलेगा या कैसे एक जैसा? कोई छोटा है, कोई बड़ा है, कैसे फ्रीक्वेंसी एक सा बदलेगा? हाउ? दैट्स राइट. तो आप कह रहे हो फिर स्पीड बदलेगा और आप कह रहे हो सिंक्रोनस स्पीड में चल रहे हो. चित भी मेरी, पट भी मेरी. कैसे? यू आर राइट, स्पीड बदलेगा, पर हर जनरेटर का एक सा ही बदलेगा? नहीं बदलेगा, डिफरेंट रहेगा. तो फ्रीक्वेंसी कहां से पता पड़ेगी क्या फ्रीक्वेंसी है? आपने 4 जनरेटर लगा दिए, महाराष्ट्र में तो बहुत जनरेटर होंगे. आपने 4 जनरेटर लगा दिए, सबकी स्पीड अलग है. तो क्या सिस्टम की फ्रीक्वेंसी, जब आप वो मेजर करोगे, क्या होगी फ्रीक्वेंसी? गलत मैंने बात पूछी? क्या होगी फ्रीक्वेंसी? करेक्ट.
Hydro will respond in a different way.
100%.
Thermal with maybe say 600 megawatt generation will give a different response. 300 megawatt will give a different response.
Agreed. I am fully in agreement with you. But then tell me, what will be the system frequency?
When these frequencies are different, they will start shutting off one generation.
फ्रीक्वेंसी विल बी डिफरेंट, बट डिफरेंट मतलब मेरे को तो यहां मेजरमेंट को करके बताओ. अपने जो इक्विपमेंट है अपने रितेश साहब के मैं लगा देता हूं यहां, तो व्हाट फ्रीक्वेंसी विल आई रीड? आपकी बात में पूरी तरह सहमत हूं. मैंने लगा दिया वहां ऑसिलोस्कोप, क्या फ्रीक्वेंसी आई विल रीड देयर? अरे वो आप तो दूसरी बात कर रहे हो. वो जनरेटर थोड़ी उसको आपके रूल्स को कहता है कि चीफ मिनिस्टर ने कहा 50 हर्ट्ज तो 50 हर्ट्ज लगाएगा. ये डायरेक्टर साहब ने कहा 50 हर्ट्ज होना चाहिए.
That means when the system is, when the frequencies are dropping, that grid will cut off that particular generating station
Yes.
and maintain the frequency for panel rest.
So 50 hertz will be maintained, but in the meantime, different generators will be running at different speeds. तो क्या फ्रीक्वेंसी होगी? ये बड़ा इंपॉर्टेंट क्वेश्चन है, ये आसान क्वेश्चन नहीं है. But everybody has to think when you are dealing with power system, what will be the what does frequency mean? ये सबसे बड़ा क्वेश्चन है. What does frequency mean? Right? ये बहुत बहुत बड़ा क्वेश्चन है ये. तो किसी को इसका जवाब नहीं मालूम. Nobody knows. But we live with that. We design controllers. We do everything. So what I'm driving at is, what is the assumption we use to do our analysis? ये तो nobody can deny. Nobody can deny that every generator will go at different frequencies, different speed of rotation. And if that happens, how would our theory handle it? वो 50.1 पे जनरेट कर रहा है, वो 49.9 पे कर रहा है, वो 50.2 पे कर रहा है, तो कैसे काम चलेगा? जैसे सर ने कहा कि डायरेक्टर साहब कह कर गए अभी 50 हर्ट्ज होनी चाहिए तो निकाल दूंगा नौकरी से, तो 50 हर्ट्ज तो आपको करनी पड़ेगी. तो कैसे ये धंधा चलता है? How do we run this system? And unless we know that, we would not know how to run the system which is coming. क्या मेरी प्रॉब्लम इज दैट जेन्युइन? कि अभी कैसे चलता है? क्या अजम्पशन हमने लगाए हैं? As far as I can understand the theory, एक बड़ा जनरेटर कोई आया, right? A big generator comes. थोड़ा लोड ड्रॉप हुआ कहीं, that generator speeds up and we assume that it is generating current at the frequency 50.05 hertz. What will happen to the other generators? Okay, so now the theory says that if this is a large generator, we take the system frequency to be 50.05 hertz. Right? अगर कोई बड़ा जनरेटर है, and this is, we all sit like that, and that's literally how it is done. We all sit like that, and we say नागपुर के एरिया में ये टॉप जनरेटर है यार, तो उसकी जो फ्रीक्वेंसी होगी, we will say that is the frequency of महाराष्ट्र. ये थ्योरी है, मैं कह रहा हूं, प्रैक्टिकल किसी को जवाब मालूम नहीं है. This is a theory I'm saying. So what engineers do, they decide that this will be, has anybody used PSSE? काम में लिया है? नहीं लिया. So have you used any simulation packages? Power system simulation packages? कौन सा?
Simulation package.
Simulation. पावर सिस्टम का बहुत बड़ी चीज है. मतलब टू अंडरस्टैंड व्हाट सिमुलेशन पैकेजेस आर डूइंग, दैट्स अ वेरी बिग थिंग एंड दैट्स अ वेरी असेंशियल पार्ट ऑफ पावर सिस्टम इंजीनियरिंग. कि पैकेजेस कैसे करते हैं, इन द सेंस जो मैं अभी आपको कह रहा हूं कि नोबडी नोस. जब डिस्टर्बेंस हुआ, जो लोड एंड जनरेशन में इम्बैलेंस हुआ, हर जनरेटर अपना काम करेगा, पर वो तो बहुत मुश्किल हो जाएगी. तो कैसे हम अपनी जिंदगी चलाते हैं? हाउ डू वी प्रैक्टिकली लिव विद दोस सिचुएशंस? सो व्हाट वी डू इज, वी से लार्ज जनरेटर 50.5 हर्ट्ज, ये बहुत बड़ा स्टेटमेंट है. What I'm writing is quite a big thing. Why are transients generated in synchronous machine? क्या कारण है? सिंक्रोनस मशीन तो आपने पढ़ी होगी कभी तो. याद है? You would have studied synchronous machine sometime, right? So we are looking at the models here, the model of power system, right? So what do we model? So sorry, मैं ऐसी खाली बात नहीं कर रहा, मैं ये कह रहा हूँ कि what do we model in power system? मैं फालतू बात नहीं कर रहा, बहुत काम की बात कर रहा हूँ. अभी अपन ने मॉडल किया, साइन वेव लगाओ, ऑसिलोस्कोप पे देखो, करो, मॉडलिंग की बात करी. तो वो मॉडल जहां ये करना है वो किस तरह का मॉडल है? व्हाट टाइप ऑफ मॉडल इज इट? राइट? एंड वी, आपने शुरू किया, आपने भी कंट्रीब्यूट किया कि लोड जनरेशन इम्बैलेंस, दैट्स व्हाट वी आर लुकिंग एट, दैट्स द मॉडल वी वांट. कि जब लोड एंड जनरेशन दे आर इम्बैलेंस, व्हाट हैपेंस? Okay, firstly, and then you suggested that the speed of the generators change. Then how do we analyze that? क्या हो जाता है? अगर स्पीड बदलती है तो क्या होता है? What will happen? So why do we get all these blackouts and all? अगर वो स्पीड बदलती है तो उससे क्या फर्क पड़ता है? Let it run at 1510 RPM, क्या फर्क पड़ जाएगा? 3010 RPM, क्या फर्क पड़ जाएगा उससे? What happens when a generator changes its speed compared to the synchronous speed? Yes, ये बड़ा point है. What happens? 3000 hertz है, I think 2 pole is 3000 hertz, right? RPM, sorry, thank you very much. 3000 RPM, 4 pole है तो शायद 1500 RPM. हाँ, 1500. So, से 4 pole है, 1500 है, वो 1510 हो गया. तो क्या ऐसा गुना हो गया? What is big deal? If it is, what happens? That's what we are modeling. And that's what is critical to understand the power system. इतनी सब discussion होता है, तो what are they talking about? क्या वो कर रहे हैं झंझट?
Frequency, in case it shoots up or reduces,
Yes.
all the transformers and all the LC circuits will behave, go haywire. The outputs will be.
Very good, very good. आप ये बहुत बड़ी बात कर रहे हैं. पर
Everything is designed at 50 hertz in India, so it has to, you have to maintain it at the national grid, which is 50 hertz.
आपको डायरेक्टर साहब की बहुत डर लगता है.
These are norms by frequency regulator in India.
आपको डायरेक्टर साहब का डर लगता है. आपको वो जनरेटर डज इट केयर अबाउट द रेगुलेटरी अथॉरिटी? What he doesn't care really. आपको बहुत भय है. Yeah, you are 100% right. We have to maintain 50 hertz and all that. So what we are trying to see is how to model the situation when it is not 50 hertz. आप समझ रहे हैं? Is the purpose of discussion clear? क्या हो जाएगा? 50 hertz नहीं है तो. When do we use load flow? So किसी ने कहा load flow की, load flow, how many of you have done load flow? Everybody? लोड फ्लो. सो लोड फ्लो हम कब करते हैं? मतलब अंडर विच, व्हाट आर द अजम्पशंस बिहाइंड डूइंग लोड फ्लो? क्योंकि सर ने क्वेश्चन पॉइंट मेंशन किया कि इंडक्टेंस है और वो डायरेक्टर साहब बहुत गुस्सा हो जाएंगे. पर अपन ये पता तो लगा डायरेक्टर साहब क्यों गुस्सा होंगे. So पहले load flow, what are the assumptions behind load flow?
Basic assumption is frequency is stable.
Very good, sir. Frequencies. Very good. Assumptions.
Based on the frequency, every equipment will be different.
So ये आपने कहा, फिर आप वो बदल दोगे. आपने यही आपने कहा ना? फिर बिल्कुल ठीक है. Any other assumption? बहुत बड़ा assumption है. डिमांड एंड जनरेशन. सो वो जैसे सर ने कहा फ्रीक्वेंसी स्टेबल है, वो डायरेक्टर साहब से घबरा गए और डिमांड एंड जनरेशन बराबर हो गई. वैसे मैं मजाक के तौर पे कह रहा हूँ डायरेक्टर साहब, पर मैं ऑस्ट्रेलिया इतने साल रहा हूँ, वहां भी चमचागिरी उतनी चलती है, सब उतना ही होता है, पर वो पॉलिट वे में होता है. तो दुनिया में कहीं नहीं है, मैं डायरेक्टर साहब का नाम ले रहा हूँ, पर दुनिया में चमचागिरी हर जगह विंस, राइट. तो इंडिया का नाम है, पर इट इज नॉट स्पेसिफिक टू इंडियंस. दुनिया भर में चमचागिरी चलती है. तो और क्या है? आपने कहा बैलेंस है जनरेशन एंड डिमांड में, और क्या असम्पशन है? बहुत ये सब चीजें बहुत महत्वपूर्ण है. एंड यू शुड नॉट जस्ट नो इट सबकॉन्शियसली, यू शुड नो इट कॉन्शियसली. आपके इट शुड बी ऑन द टॉप ऑफ योर हेड, लाइक फीडबैक हाई गेन. जैसे किसी ने कहा फीडबैक हाई गेन, जैसे किसी ने कहा फीडबैक फेस डिफरेंस, फेस लैग, वो सब आपके एकदम फिट आनी चाहिए. देन यू विल स्टार्ट टू एब्जॉर्ब थिंग्स पीपल टॉक. अभी आप इतनी सारी चीजें सुनते हो, दिमाग में अंदर नहीं जाती. लोड फ्लो का बेसिक अजम्पशन है इसका क्या मतलब है? या बताएं इसका क्या मतलब है साइनसॉइडल स्टेडी स्टेट का? पढ़. दैट्स नॉट देयर. साइनसॉइडल स्टेडी स्टेट हार्मोनिक्स हो सकता है, पर पढ़. Transient conditions are not there. So what is the consequence of that? What when that is not there, what does it, how does it help us? वो तो आप छोड़ें. अपन no transients are there. So how does it help us in our work, what we are doing, in our modeling work? When there are inductors and capacitors, so normally how do we model it mathematically? Inductor है, तो mathematically how would you model it?
Current will be lagging.
The equation क्या है? Current will be lagging 100%. Anybody? When you got inductor, when you got pardon? L into S. Good. So you model it using differential equations, right? di by dt, right? Very good. But when it is steady state, how do you what? Pardon? इनिशियल छोड़ दिया ना, अब साइनसॉइडल स्टेडी स्टेट आ गया, अपना गया, सब घर गया. तो क्या अपने को फायदा है मेकिंग दैट अजम्पशन, राइट? एंड यू ऑल नो द आंसर. वो जब जिस तरह से मैं पूछ रहा हूं, मे बी यू आर नॉट एबल टू से दैट. You can do phasor analysis. And phasor analysis में क्या फायदा होता है? पढ़.
Current is leading or lagging, that
नहीं, एनालिसिस मेरे भाई, आप जो कह रहे हो उसका कॉन्सिक्वेंस कह रहे हो. फेजर एनालिसिस में क्या फायदा है? वो तो करके, पर उसमें कंप्यूटेशनली क्या फायदा है? कुछ फायदा है फेजर एनालिसिस करके? What is the nature of equations when we say phasor analysis? What are the type, mathematically speaking, what is the nature of equations? When you do phasor analysis, किस तरह की equations आती हैं? Algebraic equations. And you said L di by dt, somebody said S. That's a very big thing to solve. How many inductors and capacitors will be there? Hundreds of thousands. So your equation order will be few hundreds of thousands. Differential equation if you want to do that. When you do it in phasor analysis, equivalent inductance, equivalent capacitance, and you are home. Algebraic equations. So that's a very powerful tool, but it all depends on Sinusoidal steady state. So all power system analysis we do, we assume that all the transients have died down. Now, how valid is that assumption? So when we are modeling, let's say, Maharashtra grid, we always assume that the entire grid is in sinusoidal steady state. Is that a valid assumption? कैसे?
If it is an assumption, then it is a
Very good, sir. Very well, sir. Very well said. Is there a difficulty with that assumption? ये बहुत बड़ा, it's a very big thing. That we assume that this network, अभी अपन ने कहा कि load and generation imbalance, right? And then we change the frequency. And voltage levels are changing all the time. So when do we get transient? If they've got an RC circuit, when do we get transient? If I change the voltage, will I get transients? I've got an RC circuit. I'm applying 10 volts. Suddenly I change it to 15 volts. Will you get transients? अगर RC सर्किट है मेरे पास और मैंने उसका वोल्टेज बदल दिया 10 से 15, तो ट्रांजिएंट आएंगे? आएंगे ना? और अपन तो वोल्टेज हमेशा, एवरी इंस्टेंट वी आर चेंजिंग वोल्टेजेस. सिंक्रोनस मशीन का वोल्टेज बदलता है कि नहीं बदलता? एंड नाउ यू आर आल्सो सेइंग वी चेंज द फ्रीक्वेंसी आल्सो. व्हेन द, तो फिर ये अजम्पशन वैलिड कैसे है? These are the very big successes of people who design power system analysis. जैसे आपने कहा assumption है तो valid हो गई, पर जिसने assumption बनाया बड़ा जोरदार assumption बनाया. See, in power system analysis there are many things, many assumptions, but they are so powerful in reducing your analysis and yet keeping it very accurate. I mean, I am quite shocked. I've been doing this business all my life. That how accurately they, suppose कोई बड़ा generator यहाँ गया या big load, I don't know what big load you have. When the big load goes and there is oscillations in the system, how closely the simulation can predict that oscillation, really always, I'm just shocked. कि जो तो कितने powerful assumption in the sense they are so much backed by practical experience that we can do simulations and get answer to something so practical as losing a load and watching the change in frequency. I'm just shocked how good those assumptions are. So my purpose in mentioning this is for you to have that appreciation of the beauty of those assumptions and what do they mean. The assumption that I can do load flow, and in power systems when you are simulating synchronous generators or power system, whatever you are simulating, every integration instant you do a load flow. That means that every 10 milliseconds or 5 milliseconds or 2 milliseconds you assume that the entire network has come to steady state. I mean, if it was just an assumption, it was just done for convenience, then we would not be able to predict things so accurately. It is good for us to understand that yes, whatever it is to, it is good to us, for us to develop an understanding with things simpler. That's one thing that's always a valid reason. But the second thing is how accurate they are in practice. That's what I can't still come to grips with. I mean, कितना complicated system होता है, and these simulations turn out to be so accurate. Okay, so now we come to the next part of the story. When load and generation they get imbalance, synchronous machines change their speed. ये आपने सबने कहा. How does it relate to stability? Or does it have any impact? वो स्पीड बदल के वो अपने स्पीड पे फिर आ जाता है, कोई बात नहीं. आप फ्री वे पे हाईवे पे जा रहे हो, 100 की स्पीड है, सामने कोई आया, यू वेंट टू 80, फिर वापस आप 120 पे आ गए. सो इज इट होता है यार, चलता है. और इज इट समथिंग इंपॉर्टेंट इनफ फॉर अस टू वंडर कि यार क्या, दिस इज समथिंग वी नीड टू मॉडल, वी नीड टू स्टडी. What is it we need to study there? That is the point I am trying to drive home, because it's a very critical point. And then when we see that, then we'll see that this new evolving smart grid or whatever with renewable energy, what do we need to study there? Because our purpose of gathering here is to what is important things to study, right? So we have to have an overall framework under which we look at different things. नहीं तो मजा नहीं आता. So when this is happening, what is it that synchronous generators do that causes a worry? Pardon?
Synchronous machine load angle increases,
Yes.
which can lead to the instability
क्यों?
because it is magnetically locked.
वो तो फिर भी locked है.
But then if load angle increases beyond certain limit,
Yeah.
it may lose that locking.
तो उसमें ओके लॉकिंग लूज किया, ठीक है, तो उसको क्या, लॉकिंग भले लूज चल रहा है कोई बात नहीं, फिर उसको सिस्टम को क्या फर्क पड़ता है.
Machine, that generator will come out of the system.
ओके जनरेटर आ गया बाहर, उसके बाद
Then that the gap.
तो जनरेटर जब चल रहा था तो क्या वो उसको सिस्टम को परेशानी दे रहा था? जब जनरेटर चल रहा था, आप कह रहे हो कि इट विल कम आउट ऑफ द लॉक, राइट? वॉज इट कॉजिंग अस एनी प्रॉब्लम? और वो अपना खुद ही परेशान था, कोई बात नहीं. It was not troubling us, it was being troubled itself.
Generation demand gap will increase more further.
But जब वो मैं कह रहा हूँ ड्यूरिंग द टाइम इट वॉज गोइंग आउट ऑफ लॉक, लॉक से निकल गया, उसको आपने ड्रॉप कर दिया, वो आपकी बात सही है. बट ड्यूरिंग द टाइम दैट वॉज हैपनिंग, वॉज इट ट्रबलिंग अस?
Yes, it must have been troubling. Otherwise, why should it drop this?
या क्या ट्रबल कर रहा था? वेरी हंड्रेड. आपको
Disturbing your frequency.
आप डायरेक्टर साहब से सीख के आए हैं. जो हो रहा है वो ठीक हो रहा है. नेवर क्वेश्चन दैट.
So it will disturb the frequency.
How?
Because this is a small generator, the entire grid is at a higher frequency,
Yeah.
and suddenly load drops.
ड्यूरिंग द टाइम, आपकी बात सही है कि ड्यूरिंग द टाइम इट इज गोइंग आउट ऑफ सिंक्रोनाइजेशन एंड वी हैव टू कट इट आउट. वो क्या कर रहा था? व्हाट वाज इट डूइंग टू द सिस्टम? वी हैव टू अंडरस्टैंड दैट फिजिकली कि क्या कर रहा था वो. एवरीथिंग डिपेंड्स ऑन दैट. What it was doing during that time, that is what we model. See, my whole emphasis is on how we model it. अपना मॉडल पे सारा दामोदार है. अगर आपने मॉडल ठीक नहीं किया तो कुछ नहीं कर सकते. तो क्या हम मॉडल कर रहे हैं? What is it we are modeling while it is running away? ये बहुत इंपॉर्टेंट बात है. अपन ने सीखा ये, वी डू दिस मॉडल्स यूजिंग. सो नाउ you would have heard about voltage regulators, right? AVR. You have heard about power system stabilizers. वो क्या कर रहे हैं? किसको स्टेबलाइज कर रहे हैं? वो कहां से, कौन सी डायनामिक्स है जिसको ठीक कर रहे हैं? वी हैव टू नो द डायनामिक्स, राइट? ये कौन सी डायनामिक्स है? क्या किस चीज को वो ठीक कर रहे हैं? पावर सिस्टम स्टेबलाइजर क्या कर रहा है? सो व्हाट्स हैपनिंग? सो नाउ वी हैव गॉट अ सिंक्रोनस मशीन. So, I mean, I don't know, when I did my degree, I think it was in Surat. So, वो चौक से मार्क करते हैं. You can mark it with a chalk, right? एक जो शाफ्ट है उसका, उसमें चौक, गीली चौक से मार्क कर दो. फिर स्ट्रोबोस्कोप से you watch once, स्ट्रोबोस्कोप once in every cycle वो चलता है, जो भी फ्रीक्वेंसी है. तो सिंक्रोनस मशीन, सिंक्रोनस जनरेटर पे अगर लोड इंक्रीज करोगे तो ये कहां, ये पीछे जाएगी आगे जाएगी? पार्डन? जैसे ये स्टैंडर्ड है, चल रहा है, आपने सिंक्रोनस जनरेटर को लोड कर दिया तो ये कहां जाएगा? पीछे जाएगा, पीछे जाएगा, पीछे जाएगा। आप सब लोग इतने कॉन्फिडेंस से कह रहे हैं तो आई एम बिट कंफ्यूज्ड। पीछे जाएगा, व्हाई वुड वो पीछे क्यों जाएगा? वो तो लॉक है, it is locked with the synchronous thing. So what is the that's the formula, right? Okay, I should have asked a different question. I am very sorry. I should have asked a different question. I give more that's what I should ask, because छोटा synchronous जब मशीन लैब में होता है तो उसको ज़्यादा कुछ ऐसा होता नहीं है, मतलब लोड आप बढ़ाओगे तो उसको क्या फर्क पड़ेगा, because it does not pick up the load, it is picks up somewhere else. So it is synchronized with the synchronous machine or synchronous grid. Generator चल रहा है and I drive it using a motor, right? And if I increase the torque in the motor or mechanical powers given to the motor, where would this go? वो थोड़ा आगे चला जाएगा, वो थोड़ा आगे चला जाएगा, because the angle delta will increase, so it will transfer more power, right? Power transfer के लिए डेल्टा आगे जाएगा. Now क्या होता है, साइन डेल्टा कब तक बढ़ता रहता है? अप टू 90 डिग्री. उसके बाद क्या होगा? ओके, जब वो अगर वो नेगेटिव में जाएगा, जैसे व्हेन इट इज suppose mechanical power is constant, that's why I put 0 there, and it is putting out more electrical power. Can it happen in synchronous generator? Sorry, I didn't want to. Yes, sir, tell me why.
That extra electrical power may be drawn from its kinetic energy.
Very good, sir. Very, very good. So this happens all the time. The electrical power is different from the mechanical power input because it has got the stored kinetic energy. So using that, it could either supply more electrical energy or it stores more, so it could supply less electrical energy. Right? अब सर की बात सबने समझ ली ना? Because the kinetic energy is there, I am supplying mechanical power, and on top of it there is a kinetic energy which converts to power, and that can also, and both the things together form electrical power. Right? So ये हो रहा है, continuously it's happening. So this can happen continuously. So if electrical power is more than the mechanical power, what will happen to this thing? How would we see that? ये क्या हो रहा है? It will go backwards, right? Or what happens when it comes to that point, exact point? What will happen then? वो वहाँ लॉक हो जाएगा? हो जाएगा लॉक? That is the reason why we get instability, because it will not lock there. It has got its own inertia. वो oscillate कर रहा है. So it will go back, forth, back. So during the time it is in the system and not cut off, it is dumping power on the system and absorbing power from the system. That's the game going on. That's what we model. क्या हम मॉडल करते हैं कि how that angle delta changes, and the change in delta will change sine delta, so it will change the power going out, and that will have an impact on its speed. Sorry, speed कहना गलत है. Physically, yes, that's right, speed. But our theoretical theory does not take that. Theory just says that delta कम हो रहा है. ये आप ध्यान रखें. ये पावर सिस्टम की थ्योरी की बहुत बड़ी स्ट्रेंथ है कि it does not, it just sweeps under the carpet the speed change. क्योंकि that is too difficult a problem. So it is continuously changing delta. And that is what we are modeling. Right? In power system, it is changing the delta, so it is changing how it is dumping power. So now when it is dumping power, what's happening? There is no load corresponding. So what will happen with the other machines? जैसे लोड तो फिक्स्ड है, राइट? ये पावर डंप करना इससे शुरू किया इस जनरेटर ने, तो वो पावर कहां जाएगी? मैडम जोर से बोलें, माइक्रोफोन दिए मैं आपको दे दूं. क्या होगा उस पावर का? लोड तो फिक्स है. क्या होगा उस पावर को? आपने जनरेटर ने पावर डंप करना शुरू किया, कहां जाएगी वो पावर? वो पावर दूसरे जनरेटर्स पे जाएगी. लोड तो आपका फिक्स है, तो मेरे जनरेटर ने पावर डंप करना शुरू किया, योर जनरेटर हैज टू एब्सॉर्ब इट. देयर इज नो अल्टरनेटिव. When it absorbs, what will happen? It will accelerate. And this guy will decelerate because it is putting out more power than the mechanical input power. So यहां से जो गड़बड़ थी वो मैंने वहां ट्रांसफर कर दी. वहां की गड़बड़ वो तीसरे को ट्रांसफर करेगा. So एक जगह गड़बड़ हुई, that will keep on transferring it unless there is a damping, there is a power system stabilizer or something you have which stabilizes that oscillation. So what are we modeling? We are modeling how generators oscillate and they dump power in each other. And oscillation is primarily because of the large mechanical inertia of the generator. Right? अगर उसमें जनरेटर में inertia नहीं होता, तो जैसे वो यहां आता, लॉक हो जाता एकदम. As soon as it came there, it could lock, but it can't lock because it has got a huge inertia. वो चल पड़ा है. It has to go that way, then that way, धीरे 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 करके वो आकर आपको फिर लाइन पे लगेगा. And in the meantime, it has caused problems to so many other generators. So if you do not stabilize it in time, so as a matter of fact, it is always oscillating. Always, there is never it is not oscillating. Always, it is not possible for it to not oscillate because there is no way you can match generation and demand, right? There is no way. There is just no way. But those oscillations are small. And because those oscillations are small, how can we model it? What did we learn in the morning? We have got linear systems, right? Although this is a non-linear system, because those oscillations are always small, we can use them linear theory, and all the things we studied before come directly to help us. So we do voltage regulator, same story. The power system stabilizer, exactly the same story. You apply a sinusoid disturbance, find out the change in power flowing and change in oscillations, the oscillation of the voltage or current, and then you damp it. Exactly the same story as we had before, right? But when the changes are large, we use other type of theory, not that one. So this is the story of what power system is happening. And ye humko hamesha we have to have always on the top of our head. So when you said frequency change, it is the change in the speed of those big generators which we constantly monitor, and that tells us there is a difference between generation and demand, and we change the between supply and demand, generation and demand. So we change the generation, that is the mechanical power going to the generator, to as a function of that change in speed, because that's the only sensor we have. So I have got a colleague, 4 years, I cannot explain to him that loads are not measured. He does research in cyber security. उसको मैं अभी तक समझा ही नहीं पाया कि load नहीं measure होता है. He's for 4 years he says, okay, they go in smart grid, they put smart meters, they measure the load and they do that. अब भाई load आप नहीं measure कर सकते. You have to have an indirect way of finding the balance between generation and load. So you measure the speed of the generator, a few generators, which are big ones, to get that. Now, if those generators are not there, how would we know whether there is a match between generation and demand? देखो मैं सब एकदम I am asking important questions because without these answers we cannot go very far. When there is no synchronous generator, how would we know that generation is meeting the demand? करंट का क्या करेंगे? करंट मेजर कर सकते हैं. हाँ फिर
When it is meeting the demand, you have X value of current.
Yeah.
And when the load increases,
कैसे करंट तो बढ़ता है, लोड के हिसाब से बढ़ेगा घटेगा. आपको कैसे पता पड़ेगा कि मैच कर रहा है कि नहीं कर रहा? भाई we have to run this system. If I have to run this system, I have to know कि generation is meeting the demand or not. अभी तो आप वो जनरेटर चलता है, the kinetic energy, the same thing you said, that the difference is supplied by the stored kinetic energy. उसमें वो धीरे होता है, तेज होता है. Very good, sir. Voltage. So you think that when the demand will not meet the supply, the voltage will change, right? Yeah. Correct. It has to change, right? What else will change? See, ये बहुत बड़ा क्वेश्चन है. What I am trying to discuss, and I don't know the answer, nobody knows the answer. How would we regulate a grid where there are no synchronous machines? अभी सबसे सिंपल मतलब we can. So, having come so far about the model, because आप लोग सोचे ना सोचे, but I think it's very important as power engineers or as researchers that you see what is the dynamics of your system you are trying to control. Now this will, I mean, it shocks me. Certainly it's a big shock. ऑस्ट्रेलिया का इतना बड़ा सिस्टम है, वहाँ 2 सिस्टम है, ईस्ट एंड वेस्ट का अलग अलग है, पर आप ईस्ट का ले लें, which is 3,000, I think it was 4,000, more than 4,000 kilometers long. बहुत बड़ा. ऑस्ट्रेलिया इस 3 गुना है क्षेत्रफल भारत से. So it's a huge grid. And they get very accurate answers using 14 machines. Just 14 machines they can use to get answers to what's happening in the grid, which is quite extraordinary. And the reason we can do it is that many people have got a very good understanding of the important dynamics of the system. So what I'm trying to tell you is that when you do research, you have to have a very good grasp of what is the essential dynamics. So when I say dynamics, what do I mean? जब मैं dynamics बोल रहा हूँ, तो आपके दिमाग में क्या छवि आ रही है? अमिताभ बच्चन की? नहीं. What image comes to your mind when I say dynamics? Parameter, yes. What is the mathematical representation of dynamics? पावर फैक्टर है पर वो डायनामिक्स से रिलेटेड नहीं, वो स्टेडी स्टेट कॉन्सेप्ट है. Yeah, so when I say dynamics, I mean differential equations, transfer function, phase change. So that's what dynamics word means, phase shift. That I am sending a signal here, when it comes back, what is the phase shift? I am injecting something here, by the time it reaches Mumbai, what is the phase shift? That is what I mean by dynamics. That there is a phase shift. Dynamics means when I inject a signal here, it will have a phase shift as it travels. So that's what so in every system you design, you are designing inverters or whatever, you say that, oh, well, it's not important because it changes so fast, which is true. It changes so fast, so you don't have to model. But many times, no, that's not true. If you are designing just the inverter and not coupling it with other things, then you are worried about even that microsecond delay. So it depends on what you are doing. But every time you have to focus on what is the essential dynamics in the system I am working with. That's the difference between people who do good research and people who do technical work. Usko iski chinta nahi hai. Right? But if you are an engineer who has got a little bit of more desire to know the system, so you have to get a handle on dynamics. पावर सिस्टम आप कभी पकड़ नहीं सकते जब तक आपको डायनामिक्स, ये जनरेटर कैसे तेज धीरे होता है. So what is, suppose there are two generators in the system. When will this तेज धीरे cause more problem? So what can you do to the system to reduce the problem? अगर आप इंजीनियर हैं तो आप क्या कर सकते हैं उस प्रॉब्लम को कम करने को? So that's the purpose of transmission system design. If you have got thick cables, these problems will not occur. If you got thin cables, these problems will occur. So it's how much money you put into the system. So why are you putting that money? It is because of these problems. So if you have an idea of how important is this problem, वो केबल ज़्यादा बड़ा छोटा पैसे लगते हैं केबल में. If you have got a thicker cable, it costs a lot more money. So if you have got a very good understanding of this dynamics, see कितना damage हो सकता है to reduce the size of the cable, you are willing to take the risk, but for which you have to have a very good understanding of what happens. So that's why for to become an engineer with an impact, you have to know the essential dynamics of whatever you are dealing with. Right? So we have come to the place where synchronous generators tell us about the difference between generation and demand. Synchronous generators cause problem because of the mechanical inertia. You get blackout because of that. Now, many people complain, I don't know, India में भी हुआ तो होगा, but you would have read about recent blackout in Spain and Portugal, right? Maybe there was a blackout there, right? So what did people say mostly? क्यों हुआ? Pardon? क्या मतलब हीट फेल का कारण क्या दिया कारण? Most of the people, what reason did they give? वो सब blanket statement है, no inertia. वहाँ के उसमें there are lot of PV systems and wind systems and all. The blanket statement and no inertia. So I personally don't think that no inertia is a bad thing. मेरी समझ में, or that I could be wrong. I mean, this is, you have to try. I'm just giving my opinion based on whatever analysis I have done. Not having inertia is a very good thing. ये क्यों मैंने इतना लंबी कहानी कही सिंक्रोनस जनरेटर की, उसका सिर्फ कारण यही था कि आपको बताना कि कैसे वो एक्सिलरेट डिसिलरेट करके वो सिस्टम में propagates the disturbance, and then you have got instability in the system when the generators start dropping out. So why is inertia good? I'm not so sure. It is bad in many ways. Now, the whole thing is when there is a difference between generation and load, What is the current solution? See, we don't have आपने जैसे कहा voltage profile change होगा ये सब, so we don't have theory for that. That is true. I'm pretty sure that is what you say is true. But we don't have a theory to use that signal and design controllers. You can do it, but अपने पास वो modeling इतना accurate नहीं है कि if I change something, what will happen to the voltage? I cannot accurately model it. Because right now, what is voltage? कैसे अपन, how do we capture the voltage information in our power system analysis? Voltage is जैसे यहाँ क्या voltage है? What type of analysis gives us that information? आपके वहाँ सब स्टेशन पे मकरन जी ने बताया था मेरे को, आपका सब स्टेशन है यहाँ, वहाँ कितना वोल्टेज होगा? What type of analysis gives me that information? Load flow. And what is the assumption of load flow? I said steady state, right? So the tools I have got to get voltage, that is assuming it's in steady state. So how would I use it to regulate the generation demand? So I have to have some assumptions, some theory to connect the change in voltage to the difference in that. And that is most welcome. I think that's a very, very profitable area of business, area of research. Very profitable. कि आप बैठ के ये एनालाइज करें, राइट, डू अ प्रॉपर लॉन्ग एनालिसिस, हैव सम एक्सपेरिमेंटल वर्क एंड वर्क आउट दैट हाउ वुड आई use that voltage information to inject more power in the system or less power or whatever, right? But upon jo abhi load flow, that's why I make it a very detailed thing that load flow is steady state, and right now what we have is steady state analysis. We do not have the transient analysis, or we don't have the differential equations which relate voltage with power imbalance, right? So जैसे इसमें d delta by dt, you got swing equation the power system में है, we don't have any similar equation for voltages, right? So that's another area. So right now, how do we do it? आप सबको मालूम है, पर मे भी अभी लंच का टाइम हो गया तो आप कह रहे हो क्या आप जवाब दें? How do we do it? कितने बजे बंद? 1:30 बजे बंद करना ना? 5 minutes? Okay. गलती कर गया क्या? We had 1.5 hours, 2 sessions, right? 10:30 to 12. So 12 to 12.
45 to 1.
1. Oh, okay, sorry. No, sorry, मैं बंद कर दूंगा. So आप मेरे को ये बताएं कि अभी कैसे ये धंधा चलता है. Many countries like Spain and Portugal, Australia, South Australia, there is a state there where there is almost no synchronous generator. ये धंधा कैसे चलता है? How do we run this business? Grid तो चल रही है ना? In Portugal, Spain also normally the grid works. So who is doing this business? In synchronous generator, जैसे आपके डायरेक्टर साहब कहते हैं उसको पावर को कम करो, based on that you know the governors and all that business, right? So we have got all that set up in systems with synchronous machine. How do we do that business for systems which don't have synchronous machines? Very good. Storage in the sense, आप इसको elaborate करें?
Maybe in terms of battery storage.
बैटरी से क्या होगा? बैटरी क्या करेगी?
एनर्जी स्टोरेज.
या एनर्जी स्टोरेज तो उससे कैसे, मतलब टेक्निकली आप मेरे को बताएं, या आपकी बात 100% you are right. So what does a battery do?
It's a load on the grid.
So I guess what our friend there suggested, that when the voltage at the terminals of the battery changes, it pumps in more power or sucks in. If it goes high, it sucks in power. It goes down, it dumps power, right? So it is roughly doing the job of synchronous machine. But what is the difference between battery and synchronous machine? Why battery is, although it's a costlier solution, what advantage do we have as compared to the synchronous generator? स्टोरेज तो है, बट क्या अपने सिंक्रोनस मशीन का व्हाट इज द बिगेस्ट डिसएडवांटेज वी डिस्कस राइट नाउ? लॉस ऑफ इनर्शिया, बट सिंक्रोनस मशीन डायनामिकली स्पीक, अपने को अब हर चीज डायनामिक मॉडल की उसमें अपन देख रहे हैं. तो what is the thing which goes wrong with synchronous machines, dynamically speaking? Pardon? Lots of, but उसके पहले क्या होता है भाई? वो ऑसिलेट करती है, वो इंस्टेबिलिटी करती है ऑसिलेशन से. So that's what I'm saying. Your focus should be on the model, dynamic model. क्या करती है? वो ऑसिलेट करती है एंड फाइनली इट रन्स अवे. बैटरी में ऐसा होगा? बैटरी डायनेमिक्स आर सो फास्ट, no problem. So if you do the battery thing properly, I cannot understand क्यों ये लोग बाग इतनी हल्ला करते हैं. Battery, of course, the solution is very expensive. Whether to have the same synchronous generator is much cheaper, but battery does that thing, and to make it cheaper, to design the system better, if we can get handle on what you said, something like that, voltage profile or some other signal which we can understand, which gives us a good idea about the difference in generation and demand, we can reduce the size of battery we need, we can use battery more efficiently, we can change the way we organize our system. We can understand, अगर नहीं है तो नहीं है, मतलब what the first thing we have to think is, if the balance is not there, what can happen? अब ये क्यों ये इंस्टेबिलिटी होती है, क्यों ये स्पेन और पोर्चुगल और इसमें सब में टूट जाते हैं सिस्टम? व्हाट इज द रीजन? क्यों ये सब झंझट हो जाता है? One of the reasons is that they do not have enough grid forming inverters. Grid forming inverters जो हैं वो कम हैं, और because, I mean this you learn later this afternoon and all these things, जो grid forming inverter है, अगर 2 grid forming inverter है तो क्या तकलीफ है? अगर 4 हैं तो क्या, जैसे सिंक्रोनस मशीन में तकलीफ है, इसमें क्या तकलीफ होगी? Grid forming inverters each will try to put out its own frequency. Right? तो आप उससे synchronize करोगे, उससे synchronize करोगे, and that's where the things fall apart. That these power sharing algorithms do not work as of now. ये बहुत बड़ी समस्या है. The synchronous machine तो बहुत आसान है, because it's a physical device, you don't have to do anything. Inverter में तो you have to tell what to put out on the terminals, and that's a bigger problem. If you don't do something and say क्या होगा, but that's not how we think about it. We think you still in the domain of synchronous machines. ये क्या होगा? And that's why we have got these. So these are very, मैं कोई नई बात नहीं बता रहा, it is all well-known facts. But I'm just trying for you to think about these problems as they occur in practice. And it will be easier for you to relate to these problems, to think through these problems, if you understand how the power system is set up now. Because it's much more simpler. Because जैसे मैंने कहा, and I'm sure that India may be models available reduced order, 14th order system, 14 generator system for the entire Australia, you can imagine that how easy it is to think what is happening. Now the systems are so complex, every rooftop has a solar, it is very hard to think till, I'm sure that one of you might come up with a theory how to do it just as well for this system as we have been doing for synchronous machine systems. Okay, I'm sure that people will come, people will make assumptions, directors साहब आएंगे कि ये assumption, वो assumption, and then we'll be back in business, but it will be a while before we don't have enough experience of this system. How is it behaving? So the whole idea of thinking about doing research or understanding this is to understand this problem. किसी भी चीज को समझने के लिए how it becomes, at least to power system, how it becomes unstable, that is the first thing you have to understand. Instability का कारण क्या है? If you can put your hands on finger on why it becomes unstable, that means you are already on your way to finding a solution. वो सबसे ज्यादा इंपॉर्टेंट बात है. तो ये बहुत बड़ा, I shouldn't say that, but I'm a bit surprised that you are not using simulation tools. As researchers, you should really extensively use all those simulation tools. Because power system में आप कुछ नहीं कर सकते जब तक आप simulation tools ढंग से नहीं चलाएंगे. बहुत complex है ये. And once you start using those tools, you will be shocked that how you can think about it in a simple way and yet get a handle on the whole thing. ये बड़ा इंटरेस्टिंग है पावर सिस्टम्स के साथ. इतना कॉम्प्लेक्स सिस्टम है एंड येट वी नो सो वेल दिस सिस्टम, एंड वेरी सून वी विल बी एबल टू डू इट सेम विद डिस्ट्रीब्यूशन सिस्टम्स एंड ऑल दैट. सो मैं जो कहना चाह रहा हूँ, अभी तो मैंने, आई थिंक आई हैव कम हाफ वे थ्रू माई स्लाइड्स, बट दैट्स ऑल राइट. I mean, you have to forgive me for this, but I somehow think these things are very important. मतलब आपने मेरे को यहाँ बुलाया है, so I have to share with you how I think about these things. Whether it seems to relate, but they are all related to modeling the system to get the relevant information. ये मेरी theme है. मैं एकदम arbitrary आपको नहीं इधर उधर फेंक रहा. Everything is related to the theme of how to get mathematical models to extract the relevant information. और अपने केस में instability, load generation match. Okay, sir, I am very sorry to take. Somehow I thought it is 1:30. I am very sorry. Okay, thank you very much.
Okay.
We'll continue later.
Thank you. Thank you very much, sir, for today's session. You kept us in that small time, like a transient time, and we understood what exactly the transient with the synchronous generator and what the challenge in front of us when it is in the inverter system. And really we have to think and come out with some solution. I hope that ignite something in our mind and find out the solution and maybe a research problem for some of you. Thank you, sir. It was very interesting and interacting, and thanks for all the participants for good interaction also. And it's really interactive session. So what we'll have today in the afternoon, we have such little change in the schedule. So the today's session is shifted. Today's afternoon session is shifted in the 2nd July. Okay. And today I will continue with my own lectures related to inverters and this selective harmonic elimination. So we'll discuss some issues related to inverters, okay, leakage currents for the solar photovoltaic inverter system. Okay, so today we'll continue the only lectures part, and tomorrow afternoon session will be continued with the hands-on part, like a simulation for the grid connected inverter part. Okay. And tomorrow, of course, we are again coming with the Professor Himanshu Pota, sir, what he will give us the direction. Okay, thank you, sir. So we'll go for lunch. So shall we have the photo session today? Or everybody is hungry, so we can continue in the afternoon maybe. Sorry, should not wait for you. Yeah. So we'll go for in the guest house. We'll go. Okay. Room will be locked. Key is there. ये गिर गया नीचे.